sigma is constant, pwede mo siyang ilabas, diba? So this is the integral of dA, so with respect to the whole area. So alam natin na equal lang yan sa area. So therefore, this is sigma times the area. Diba? So pag nangyari yan, so then if we use the equation for x sub m bar, diba? So times the mass. So then this is equal to, so again, that's an integral, diba? So ng sigma, this will be our x sub m, diba? So then this will be dm, so over the entire mass. Okay, okay ba? So but then, diba? So alam natin na, okay? So yung mass natin, diba? So is just equivalent to sigma times the area. So while yung dm natin, diba? So is equal to sigma, so times dA. So this will be over the entire area, diba? But since yung sigma natin ay constant, so we can factor that out. Okay? So then, so we can write this as sigma, so then integral ng x sub m times dA, so over the entire area. So then magka-cancel to. Diba? So ano mapapansin natin dito? Okay? So yung equation natin, kamukha lang ng equation ng sa centroid. Okay? Okay ba? So kaya yan yung kalalabasan. Pag ginawa natin yan sa y-coordinate, ganun din dapat yung lalabas. Kasi pareho lang naman ng composition yung sa x-coordinate saka sa y-coordinate. So therefore, diba? So we can assume that if homogeneous, diba? So yung lamina natin, so this is homogeneous. Okay? Okay ba? So then yung x sub m bar natin is just equal to x bar. Tapos yung y sub m bar natin is just equal to y bar. Okay? So the center of mass coincides with the center of area, diba? Or the centroid. Okay? Okay ba? Centroid of an area. Pareho lang sa center of mass. Kaya pag nakakita kayo ng ganyang problem, homogeneous lamina, solve nyo lang yung centroid. Diba? And this is a parabola. This is a linear equation. So we can actually solve this without integration. So unahin natin using integration, then yung kasunod using without integration, no? Or without using integration. Okay, so let's graph first. So let's start with the parabola. Okay, so we have x is equal to y squared plus 1, no? So we can write this as y squared is equal to, so we have x minus 1. So this is x minus 1. So since meron nakasubtract kay x, diba? So ang ibig sabihin, so this is of the form. Okay, so y minus k squared. Okay, so then this is equal to, so we have 4a times x minus h. So positive yung x. Diba? So kaya alam natin this opens to the right. Diba? So opens to the right. Okay, so kasi y yung naka-square, positive yung x. Diba? So opens to the right. Diba? So tapos, ano pa masasabi natin? Vertex is located at HK. Okay? Naka ba? So again, so yan yung makukuha natin dyan. Diba? So therefore, so using that concept or that information, so then, so yung vertex natin, so will be located at, yung h natin ay 1, yung k natin ay 0. So this is the vertex, this opens to the right, no? And again, so for the other points of the parabola na concern tayo, so will be yung point of intersection with the linear equation, diba? So i-equate lang natin to sa ito, diba? So we have x is equal to 2y, so that's for the linear equation, and also equal to y squared plus 1 for the parabola, diba? So therefore, rearranging this, you will get y squared minus 2y plus 1 is equal to 0, diba? So which we can factor as y minus 1, okay? Okay? So times y minus 1. So this is equal to 0. Diba? So or will give us y is equal to 1. Okay? Naka ba? So yun yung point of intersection natin. Okay? So again, so we have y is equal to 1. So if y is equal to 1, so by substitution, remember, x is equal to 2y. So kaya 2 times 1 is 2. So x is equal to 2. So therefore, this is one of the points of intersection. Okay? Yung pangalawang concern natin is yung sa y is equal to 0. Diba? So kasi that's another boundary. So at y is equal to 0, substituting this sa parabola natin. So you will get x is equal to 0 squared plus 1. So we have x is equal to 1. So this is 0.10. Okay? Nakuha ba? So tapos, pangatlong concern natin is yung intersection ng line natin sa kanitong line na y is equal to 0. Diba? So then substituting y is equal to 0 dun sa line. So we have x is equal to 2 times 0. So we have x is equal to 0. So this corresponds to the point 0, 0 or the origin. Okay? Nakuha ba? So yun yung mga tatlong points na kailangan natin. So again, para may graph natin na maayos yung figure natin. No? Okay? So again, first, diba? So again, for the parabola, important part, vertex is at 1, 0. Okay? So x-axis, y-axis, 0. So again, yung mga points natin. So we have 1, 0. Okay? So let's say this is 1, 2, 1, 2. No? Okay? So again, first is the vertex of the parabola. That's at 1, 0. That will be this point. Diba? Tapos yung intersection niya with respect to the with respect dun sa line natin, that is the point 2, 1. So that will be this part. Okay? So ibig sabihin, so this will be our parabola. So kalahati lang yung concern natin dito. Okay? So kasi yan lang yung involved dun sa parabola natin. Diba? So again, for the intersection, for the line, diba? So again, aside from this intersection, so yung sa 2, 1, so again, intersection niya with our y is equal to 0, that's actually the x-axis, diba? So it's at the origin, 0, 0. So dumadaan din dito yung line natin. So therefore, so this will be our line. Okay? So this will be our line. Okay? Okay ba? So tapos again, so yung pangatlong boundary natin, y is equal to 0, is passing through 0, 0, and 1, 0. Diba? So kaya again, alam natin yan yung x-axis. So therefore, we are talking about this area here. Diba? So ito yung hinahanapan natin ng centroid. Okay? So again, in this case, ano yung magandang gamitin? So this, we better use here the horizontal strip. Diba? So rather than the vertical strip. Okay? Bakit horizontal strip this time? Okay? So kasi, okay, so sa vertical strip, makikita natin na pag tinignan natin yung mga vertical lines na to, so again, magkakaroon tayo ng dalawang interval dito. Diba? So kasi dito, sa part na to, sa kaliwa nito, ang boundary natin is the line, so and the x-axis. Diba? So pero dun sa kanan, ang boundary natin is yung line saka yung parabola. So kaya basically, meron tayong dalawang different boundaries, diba? So for two intervals, diba? Kaya hatiin pa natin sa dalawang interval. So kaya para isang integration lang tayo, so then doon na tayo sa horizontal strip. Kasi doon sa horizontal strip natin, kung makikita natin dito sa figure, so ang boundary lang natin lagi is yung line sa kayong parabola. Diba? So isa din yan sa mga consideration natin, syempre, diba? So boundaries. Okay? So let's use, diba? So horizontal rectangular strip like this one. Okay? So makikita natin yung thickness natin dito, diba? So is along the y-axis, no? In the vertical direction. So that's why this is dy. So then para naman doon sa length niya, so we have this length. So itong length na to, diba? So again, makikita natin na, so again, if we define this, diba? So this is our parabola. So kailangan natin dito is the x component, diba? So kaya from here, pwede natin makuha yung x is equal to y squared plus 1. So we can write it here. So we have x is equal to y squared plus 1. This is our right boundary. Diba? So then for the left boundary naman, so equation itong line. So ang equation ng line natin, so is this one, x is equal to 2y. Diba? So this is x is equal to 2y. So ito naman yung ating left boundary. Diba? So this is just given by, so yung x sa right boundary minus yung x sa left boundary. Okay? Okay ba? So then, since we are solving for the centroid, so we need to locate the centroid of this one. So again, nasa pinakagitna. Okay? In terms of the x-coordinate, diba? So again, pareho lang siya dun sa x-coordinate ng dalawang points natin, or y-coordinate pala, ng points natin. So okay, that is just given by y. Diba? So as for this one, diba? So dun sa x-component naman nung centroid nila, makikita natin that this is just the midpoint between the left and right boundaries. Diba? So ibig sabihin, this is xl plus xr divided by 2. No? Okay? Sa akin, ano siya, midpoint, diba? So, yun yung equation natin para sa midpoint, diba? Okay? So, then, okay? So, let's solve, diba? So, start tayo sa area. Okay? So, para dun sa area natin, okay, so we can solve for dA first, the differential area. Okay? So, for the differential area natin, okay, so this is given by, okay, so again, area lang siya ng rectangle na to. So that's base times height lang. So we have XR minus XL. So this is multiplied by dy. Diba? Yung XR natin, so is y squared plus 1. So this is y squared plus 1. Yung XL naman natin is 2y. So we have minus 2y. So then this quantity, dy. Okay? Okay? So again, so yan yung differential area natin. So actually, we can simplify this as y minus 1 squared. Pero kahit hindi nyo naman siya i-simplify, okay lang. No? So kasi isosolve nyo rin lang naman to sa calculator. So to solve for the area, so ang area natin dito, diba? So will become, so the integral, diba? So of y minus 1 squared. So then this quantity dy. So then, so this is dy. So therefore, it must be evaluated dun sa bottommost part. So that is 0 hanggang dun sa topmost part natin. So remember, this point is 2, 1. So ibig sabihin, this is at 1 unit. Diba? So kaya this will be from 0 to 1. Okay? So then, so what will be our area? Okay? So we have, okay, so integral, diba? So ng y minus 1. Quantity squared. So this is from 0 to 1. Okay, so you will get that this is 1/3. No? So meron na tayong area. So so we have another way to solve for the area. That is by means of direct formula. Diba? Kasi makikita naman natin yung shape niya. So ganito yung shape niya. Diba? So then, so pag in-extend natin to, so then ito, so makikita natin na isa sa mga nagko-compose sa area natin, so isa triangle. Okay, so from the figure, so yung triangle natin has, okay, so from 0 to 2, so yung base niya, so that's 2 units. Yung height niya is from 0 to 1, so this is 1 unit. So right triangle lang to. So we can solve the area. Kailangan lang nating ibawas, diba? So yung parabolic segment natin. Okay? So yung parabolic segment naman natin dito na ibabawas natin, so has a base of 1 unit so and a height of 1 unit. Diba? So 1 unit, tapos 1 unit din to. Okay? So kaya therefore, so another way, okay, so para ma-solve natin to, so will be, okay, so we have 1/2, so times base times height, minus 2/3, diba? So okay, so this is times base times height, diba? So you will get that the area is equal to 1/3. So again, this is without integration, diba? So kaya rin natin tong i-solve without integration. Okay? So any questions para dito? Okay. So then, diba? So let's calculate the centroid kasi yung center of mass natin is pareho lang sa centroid for this problem, diba? So let's start with the x-coordinate of the centroid. So for the x-coordinate, sa akin, ito yung gagamitin natin doon sa loob ng integral. Okay? Nakuha ba? So then, sa akin, so equation natin is x bar, so times the area. So is equal to integral over the area, so ng x sub c, so times the differential area. Diba? So akin yung na-solve natin na area is 1/3. So this will be 1/3. So and as for this one, so integral, diba? So ano yung x sub c natin? So again, that's x sub L plus x sub R divided by 2. Okay? So how about our differential area? The differential area is y minus 1 quantity squared dy. Diba? Okay? So this will be y minus 1 quantity squared dy. No? Okay? So again, limits of integration natin. So this is dy, kaya from 0 hanggang 1. No? So this will be from 0 to 1. Okay? So again, ano yung x sub L natin? So x sub L is yung line. Diba? So that is yung 2y. X sub R naman natin is yung y squared plus 1. So kaya this will be 2y plus, okay? So this is y squared plus 1. So divided by 2. Okay? So then this will be times y minus 1 quantity squared dy. So then this is equal to, so again, we can factor out 2, 1/2. No? So integral from 0 to 1. So then, so itong quantity na to, pwede natin siyang i-simplify as y plus 1. quantity squared. Diba? So times y minus 1 quantity squared dy. Diba? So let's try to solve this one. Okay? So we have 1/2. So times integral. Diba? So ng y plus 1 squared times y minus 1 squared. So then this is from 0 to 1. Okay? So this is x bar. So times 1/3. So then this will be equal to 4 over 15. Okay? So kaya lalabas dito, x bar natin is equal to 4/5. Okay? Okay ba? So meron na tayong x coordinate. So looking at the choices, isa lang dyan yung merong 4/5 na x bar. Diba? So kaya most likely ito yung tamang sagot. Diba? So pero to check, let's try to solve for y bar. Okay? So y bar times the area is equal to integral over the area. So ng y sub c dA. So yung lalabas dito is y bar times 1/3. So is equal to, so integral. Sa akin, ano yung y sub c natin? Y sub c natin ay simply y. Diba? Okay? So kaya y. Ang dA natin, ito lang. Diba? So that's y minus 1 quantity squared dy. So then, ang limits of integration natin, 0 to 1. So ito kaya-kaya na natin i-solve. So lipat ko yung 3 dito. Multiplied by, so let's try to solve this one. Okay? So integral, so ng y times y minus 1 squared. So this is from 0 to 1. No? So this is 1 over 12. Okay? So ay tama lang. So this is equal to 1/4. So therefore, so yung center of mass natin, tawagin ko as M. So again, this is x sub M, so y sub M. So again, since this is a homogeneous lamina, so this is just equal to the centroid, x bar, y bar. Diba? So again, so this is equivalent to, okay, so we have 4/5, 1/4. Okay? Okay ba? So any questions? Okay. So again, kung ayaw nyo dumaan ng integration, diba? So gamitin lang natin yung ginawa natin kanina to sa figure. Diba? So that is by considering the figure, diba? So to be a triangle minus a parabola. Diba? So pwede mo siyang isipin na, okay, so itong triangle na to, so with a base of 2 units, diba? Height of 1 unit. Okay? Okay? So tapos itong parabolic segment na to, ibabawas natin din sa triangle. So yung base nito is 1 unit, so yung height nito is 1 unit. Okay? Okay ba? So then, so nakuha na natin yung area, so that's equivalent to 1/3. So we can focus on the smaller areas. No? So again, so let's start with the triangle. Okay? So for the triangle, so this is for triangle. Okay? So the area, okay, so tawagin ko as A1. So this is equivalent to 1/2 times base times height. So then this is equivalent to 1 square unit. Okay? So again, this is A1. Diba? So and para doon sa centroid niya, diba? So remember, nandito yung x sa y axis natin. Diba? So doon sa figure natin kanina. So this is the x-axis, y-axis. So then this is the origin. Okay? So yung tatandaan natin pag right triangle, no? So pag meron tayong right triangle, so yung centroid niya is somewhere here. Diba? Such that, okay, so yung layo nito mula sa base, so ito, okay, so is 1/3 ng base. Yung layo niya mula dun sa gilid. So again, if this is the base, no? And if this is the height, okay, so yung layo nito mula sa base, so ito, so this is the height divided by 3. Okay? So ibig sabihin, so dito, so yung centroid ng triangle natin will be around here. So such that, diba? So yung layo nito mula dito sa gilid ay 1/3 ng base. Ibig sabihin mula dun sa vertex dito. So this is 2/3 ng base. Diba? So meaning, so yung YC1 natin or yung Y1 natin, Y1 bar, diba? So this will be given by, okay, so this is 2/3 ng 2 units. So this is 2/3 times 2. So that's equivalent to 4/3. Okay? Okay ba? So for the, sorry, X pala to, not Y. Okay? So kasi siya ay layo from the from the y-axis. No? Okay, so tapos yung layo naman ito from the x-axis. So again, that's from the base, kaya ito ay 1/3. Diba? So nung height. Diba? Yung height natin, 1 unit. Diba? So kay y1 bar is equal to 1/3 ng 1 unit. So this is equivalent to 1/3. Okay? So meron na tayong sa triangle. So yung next is yung sa parabola. Diba? So for the parabolic segment, so for the parabolic segment. Okay? So then we have yung area. So tawagin natin as A2. So again, this is 2/3 times base times the height. Parehong 1 unit. So then this is equivalent to 2/3 square units. Diba? So as for naman dun sa centroid niya, diba? So again, yung direct formula natin, pag half parabola, so kasi half parabola to, kailangan alam lang natin kung nasaan yung base tapos kung nasaan yung height, diba? So ang trick lang dyan, hanapin nyo kung nasaan yung vertex, diba? Nasaan yung vertex natin? So nasa 1, 0. So nandito yung vertex, diba? So which means, ito yung vertex natin, okay? So from the vertex, yung katapat niya, that's the base. So rin itong nasa gilid, siya yung height, diba? So therefore, so the centroid is somewhere around here, no? Okay? Okay, so ito. So tapos yung layo niya from the base, the base is equal to, so this is 2/5 ng height. Okay? So tapos kung hindi ako nagkakamali, ang layo niya from the height, so yung layo niya naman mula dito, okay? So this should be 3/8 the base of the base. So either 3/8 or 3/10, no? So check muna natin sa 3/8, no? So parang yan kasi yung naaalala kong value niya. Okay? So that's 3/8 of the base, diba? So therefore, okay, so pagdating dun sa, okay, so yung sigurado muna tayo. So let's start here from the y-axis, diba? So again, so from the base, that's 2/5 ng height. Ibig sabihin dito siya ay 3/5 ng height, diba? So kaya ibig sabihin, so dito yung x bar natin, so x2 bar. So this is 3/5. Ang height natin is, hindi pala mula dyan, sorry. Mula sa vertex lang, no? So remember that this is 1 unit mula dito hanggang dito. That's 1 unit. Tapos ito ay 3/5 ng height. Okay? Okay ba? So that's why, or hanggang dito. Let's say nandito yung centroid natin. Okay? So then this is 3/5 ng height plus 1. Diba? So kaya this will be 3/5 ng 1 unit plus 1 unit. So then this is equal to 8/5. So again, so that is our x2 bar. Diba? So para sa y2 bar naman natin, so again, this is measured from the height. Okay, so let's say nandiyan din siya. So again, so this is equivalent sa 3/8 ng base. Diba? Ito yung base natin, also 1 unit. So this is equal to 3/8 times 1 unit. So this is equal to 3/8 unit. Okay, nakuha ba? Tapos remember again na yung buong figure natin, so itong figure na to is just the triangle minus the parabola. Diba? So therefore, so dito ka na lang isolve. Okay? So therefore, so start tayo sa x bar. So again, x bar times the area is just equal to, so again, x1 bar, so times a1. Since minus parabola siya, so gagawin lang natin tong minus. So we have x2 bar, so times a2. Okay? So again, so x1 bar, so is 4/3, no? Ang area niya is 1 minus x2 bar is 8/5. So tapos ang area naman nito ay 2/3, no? Tapos again, this is x bar, so times 1/3. So let's try to solve for x bar here. Okay? So pag sinolve natin si x bar, so we have 4/3 minus 8/5 times 2/3. So then that's times 3. Diba? So you will get this is 4/5. So as you can see, pareho lang siya nung na-solve natin dito. Diba? So para sa y bar naman, so y bar area is equal to, so y1 bar a1 minus y2 bar a2. Diba? So then this is y bar, so times 1/3. So this is equal to, so ang y1 bar natin ay 1/3. Ang a1 natin ay 1. Diba? Ang y2 bar natin ay 3/8. Okay, so then, ang a2 natin ay 2/3. No? Okay? So then, so this will be 1/3 minus 3/8 times 2/3. So then, times 3, diba? So tama yung equation natin. So we have 1/4. Okay? So this is our equation. Okay? So pag na-encounter nyo naman is yung tinatawag na spandrel, no? Parabolic spandrel. So ito yung nasa kabilang side ng parabolic segment. So ganito yung tinatawag nating spandrel. Para siyang right triangle pero yung hypotenuse niya is parabolic. Diba? That's a parabolic spandrel. Okay? So that is in this case, if this is the base, this is the height. So again, so ito yung vertex, no? So ito yung vertex ng ating parabolic spandrel, diba? So then yung centroid natin is located here. Okay, nakuha ba? So tapos, yung layo nito mula sa base, okay, so ito. So this is given by h over 4. Okay, nakuha ba? So remember sa triangle, h over 3. So pag parabolic spandrel, h over 4. Diba? So tapos yung layo naman niya, so from the height, so ito. So for the centroid, okay? So ito yung 3 over 10. Okay, so times the base. Okay? Nakuha ba? So any questions para dito? Okay? So pwede nyo rin tandaan yan. Diba? So kung gusto nyo. Okay? So para pag naka-encounter kayo ng spandrel, so direct formula na rin lang. No? Okay? So any questions so far? Okay? Nakuha ba? Sa akin, so yan yung center of mass natin. Okay? So then, next topic tayo. So this time, so moment of inertia naman. So yung pag-aaralan natin. Okay? So moment of inertia is para din lang siyang centroid or yung ginagamit natin to measure the centroid. So although, instead of x, diba? So or instead of degree 1, yung ginagawa natin doon sa coordinates, ang ginagamit natin ay second degree. Diba? Okay? So kaya for moment of inertia, okay? Okay? So for moment of inertia, diba? So ang gagawin lang natin dito is, okay, so yung equation natin dito is the moment of inertia, so the differential moment of inertia. So again, this is for a differential area. So this is given by, so we have r squared multiplied by the differential area. Diba? Tapos i-add lang natin lahat ng differential area so for the whole area. Diba? So ibig sabihin, diba? So if we want to get the moment of inertia with respect to a certain axis, so this will be given by the integral, so ng r squared dA. So this is with respect to the area. Diba? Okay? So ito yung tinatawag din natin as the second moment. Diba? So kasi kung napansin nyo dun sa centroid natin na equation, diba? So basically we have r bar times the area, diba, is equal to, so this is second moment of an area. Okay? So again, so yung r bar times the area is equal to integral, so over the area ng r times a, diba? Ganito yung format nung sa centroid, diba? And makikita natin, RDA, sorry. Okay, so makikita natin, pareho lang siya ng moment of inertia, pero dito second power, dito first power. Kaya ito tinatawag natin to as the first moment, diba, so of an area. So actually marami to, diba? So umaabot hanggang fourth moment, no? Fourth moment of an area naka-raise din sa 4, diba? So depende kasi kung ano yung kailangan nating i-measure, diba? So for the problem. For example, pag center of pressure, diba? So may kinalaman na siya sa moment of inertia, no? Okay? So any questions? Okay? So yan yung tatandaan natin. So pag moment of inertia, so ganito lang. Okay, so mind nyo lang yung R, diba? So yung R natin is the distance kung saan natin sinosolve, diba? So yung distance ng area or ng differential area natin kung saan natin sinosolve yung moment of inertia. So for example, pag sinabing with respect to x-axis, so kailangan kunin natin yung distance niya mula sa x-axis, diba? Pag with respect to y-axis, diba? So then mula sa y-axis, okay? Pag with respect sa origin, so then dapat mula sa origin, no? So let's try an example. Okay. So we have another parabola here. Okay. So yung parabola natin is y squared is equal to 4x. Diba? So as you can see, so this is of the form. Okay. So y squared is equal to 4ax. Diba? So again, ang makukuha natin dito, the vertex is at 0, 0. Kasi wala nakasubtract sa y and x. Diba? So and pangalawa, so this opens to the right. Diba? Kasi y yung naka-square, so tapos positive yung x. Okay? Okay ba? So then, so kunin natin yung boundary niya. Boundary is the line x is equal to 1. So then at x is equal to 1, so we have y squared is equal to 4 times 1. So which will give us y is equal to plus or minus 2. So which means, this is the point 1, 2, saka 1, negative 2. Okay? Okay ba? So then, pag ginraph natin siya, so ganito yung kalalabasan. So makikita natin wala naman tayong limitation tungkol dun sa quadrant. Diba? So therefore, buong parabola yung consider natin dito. No? Okay, so meron kasing ganito rin problem, tapos ang nakalagay lang first quadrant, no? So ingat kayo dun. Okay? Okay? So let's say this is 1. So this is 1, 2, negative 1, negative 2. Thus this is 1, 2, no? So therefore we have the vertex, we have the point 1, 2, saka 1, negative 2. So this is the line, x is equal to 1. Diba? So then this is the parabola. Okay, so ito yung kinukunan natin ng moment of inertia. Okay, nakuha ba? So tatandaan natin ang hinahanap natin dito ay with respect sa x-axis, no? Pag ang hinahanap natin is with respect sa x-axis or sa y-axis, ang pinakamagandang gamitin is rectangular strip na parallel dun sa hinahanapan natin na axis. For example, dito x-axis is horizontal, so therefore we better use the horizontal strips. Okay? So yung reason, 'di ba, is pag horizontal strip, pag kinonsider natin lahat ng points sa horizontal strip natin, equidistant lang siya from the x-axis. So lahat sila equal sa y-coordinate, 'di ba? So nung parabola natin. Okay? So lagi pare-pareho sila ng y-coordinate so with the point on the parabola. Okay? So kaya yan yung pinakamagandang gamitin, horizontal strip. Pag with respect sa y-axis, pinakamagandang gamitin ay vertical strip. Pag with respect to the origin, so ang pinakamagandang gamitin ay double integration, no? So kung hindi man double integration, para siyang circular strips. Okay? Nakuha ba? So or parang mga circular arcs, 'di ba? So yung gagamitin niyo doon. Okay? So pero again, 'di ba? So dito sa problem na 'to, ang pinakamagandang gamitin ay horizontal strip, no? Okay? So the thickness, so as you can see, is along the vertical. So kaya ibig sabihin this is dy. So and para sa length naman na to, 'di ba? So remember, so the right boundary is this one. That is x is equal to 1. So this is the right boundary. The left boundary naman is the parabola. So again, from this equation, okay? So we can say that this is x is equal to y squared over 4. So this is x is equal to y squared over 4. So this is our left boundary. 'Di ba? Okay, so then, so pag kinuha natin to, so this is simply x right, diba, minus x left. Diba? Okay, so therefore, so let's start with the differential area. Okay, so the differential area is simply equal to, so xr minus xl multiplied by dy. Diba? So yung xr natin, so is given by 1. xl is y squared over 4. So then this quantity dy. No? Okay? Nakuha ba? So the next step is the moment of inertia with respect to the x-axis. Diba? So again, so dito ang titingnan natin is yung r squared dA. Yung r natin being y. So ito yung gagamitin natin r. Kasi yun yung layo from the x-axis. So therefore, this is y squared. Yung dA natin is simply 1 minus y squared over 4 dy. So therefore, solving for the moment of inertia, so this will be the integral of y squared times 1 minus y squared over 4. So this quantity dy. So this is from 0 to, from negative 2 to 2. Diba? Kasi consider natin lahat ng horizontal strip. So from negative 2 to positive 2. So negative 2 to positive 2. Diba? So this is our moment of inertia. Diba? So we have integral. Diba? So ng y squared times 1 minus y squared over 4. So this is from negative 2 to positive 2. No? Okay. So you will get, so 2.133. Diba? So ganyan lang yung moment of inertia. No? Okay? Nakuha ba? So any questions? Okay, so para dito. Okay? Okay? So next. No? So force on a submerged plate, diba? So or yung tinatawag natin na fluid force. Okay? Nakuha ba? So dito basic lang yung idea natin, diba? So we have, let's say ito yung surface natin. So this is the fluid surface. So tapos merong nakalubog dito na plate, diba? Okay? So syempre, diba? Yung idea kasi natin dito, diba? So is basically, so imagine nyo ito yung side view ng plate natin, diba? So this is the side view of the plate. Okay, so then, so meron ditong force, meron siya nararamdaman na force, diba? Doon sa ilalim ng tubig, diba? So which is proportional doon sa tinatawag natin na fluid pressure, diba? And alam natin na yung fluid pressure, palaki siya ng palaki. So habang bumababa o lumalalim tayo dun sa fluid natin. Mas malalim sa fluid, mas malaki yung fluid pressure, mas malaki yung fluid force. Diba? So kaya ito, so this is not your average na, kumbaga ina-average lang natin yung force, no? So again, so this is different. So kailangan natin i-consider so yung increasing pressure, so para dun sa total force natin. So kaya gumagamit tayo dito ng integration, no? So again, so ang ginagamit natin dito usually is a horizontal strips, no? Okay? So horizontal strip. Bakit horizontal strip? Kasi nga every point dun sa horizontal strip natin is equidistant mula dun sa surface, 'di ba? And we can define this as h. Okay? So kasi pag alam natin yung height, 'di ba? So then we can say that the pressure experienced, 'di ba? So by this differential area, 'di ba? So again, so yung pressure na may experience niya so will just be given by, so this is omega, so multiplied by height h. Okay? Naka ba? So again, that's the pressure natin, 'di ba? So again, sa position na to, okay, so again, so nung dun sa area natin, 'di ba? So therefore, for this differential area, the differential force experienced, 'di ba? So will be given by pressure multiplied by the differential area. Remember that pressure is force over area. Kaya force natin is pressure times the area. And since yung pressure natin is omega h, so then we can write this omega h dA. Diba? So therefore, yung fluid force natin is the integral over the area. Diba? So ng omega, so times h dA. So this is one equation. Okay? Nakaba. So ano yung omega natin? So omega is yung tinatawag natin na specific weight. Okay? Nakuha ba? Pag specific weight, so ang ibig sabihin nito, this is weight divided by the volume. Okay? Nakuha ba? In some books, 'di ba? Ang ginagamit dito na unit na symbol ay rho. Pero sa lecture namin usually omega yung ginagamit namin kasi yung rho is para sa mass density. 'Di ba? Okay? So kaya yung omega yung ginagamit namin for specific weight. Pero again sa ibang problem makikita niyo nakalagay is rho. 'Diba? So pero makikita natin yung unit is weight, 'di ba? Halimbawa ng weight is newton, 'di ba? So naka-newton per cubic meter. So omega 'yon, 'di ba? Pag pounds per cubic foot, omega 'yon. Okay? Okay ba? So ang tatandaan lang natin dito is yung sa water. So kasi kadalasan pag water yung given, hindi siya given, no? So pag water yung nasa problem, hindi given yung omega. Okay? So yung omega natin for water is 9.81, so kilonewton per cubic meter. No? So pag English unit naman, so we use 62.4. So this is pounds per cubic foot. Okay? Pag hindi lang given sa problem yung sa water. Pero pag may given naman sa water, kung ano yung given, so yun yung gamitin niya. Okay? So yan yung force natin. So now, if, okay, so omega is constant, di ba? Pag constant yung omega natin, pwede natin siya ilabas ng integration. So therefore, the force will be omega, so integral ng HdA, so over the area. But as you can see, itong term na to, this is the first moment, diba? So first moment of an area. Okay, so pag first moment of an area, equal lang siya dun sa centroid times the area, diba? So therefore, pag alam natin yung location ng centroid nung nakasubmerged na plate, so kahit hindi tayo mag-integrate, diba? So this is simply omega h bar times the area. Okay, ba? So yung dalawa yung tatandaan niya, diba? Pag alam niyo yung equation ng area, saka yung location ng centroid, hindi niyo na kailangan mag-integrate, diba? Familiar, diba? So kasi ganyan din yung ginagawa natin sa solid of revolution, diba? So kaya again, sobrang laking advantage para sa atin pag memoryado niyo yung equation ng area saka yung location ng centroid for common figures, diba? So ganun din naman dito sa mga submerged plate. Ang mga common dito ay conic sections, so tapos triangles and rectangles. Okay, naka ba? So pareho nung sa solid of revolution, no? So yun din yung mga common. Okay, naka ba? So any questions para dito? Okay. So we will try some example. Okay.
Recording stopped.
Okay, saglit lang, no? Wala ko ng tubig.
Recording in progress.
Okay. So let's start again. No? Okay. So again, so let's try this problem. No? So dito, so we have a rectangular plate. No? So again, so let's say ito yung surface natin. So we have the surface. Okay, so then we have a rectangular plate, 6 meters by 8 meters. Submerged vertically. So since nakalagay dito, submerged vertically, so ibig sabihin, yung 8 meters natin, so dapat siya ay vertical. Diba? Dapat mas mahaba yung vertical sa horizontal. So kaya ganito yung orientation niya. Diba? Submerge vertically. Diba? So tapos, find the force on one face if the shorter side is uppermost. So ibig sabihin, nasa pinaka-tuktok yung ano natin. Nasa pinakataas. Diba? So yung ating shorter side, so that's 6 meters, and lies in the surface of the liquid. So kaya nandito siya sa surface ng fluid natin. Diba? So meaning this is 6 meters. Okay, so then this is 8 meters. Okay? So again, so we have two ways to answer this problem. So again, the first way is by using, okay, so the horizontal strip. No? So like this one. Okay? So sa horizontal strip, so ititreat lang natin yung layo nito from the surface as h. So like so, diba? So then, so yung kanyang thickness, diba? So will be dh. Okay, nakabe? So tapos yung width niya, as you can see, rectangle to, sa rectangle, constant yung width. So lagi itong equal sa 6 units. Okay, nakabe? So basically, so if we solve for the differential area, so the differential area here is equal to 6 dh. Okay? Okay ba? So, ganyan lang. Diba? So, then solving for the differential force. So, again, this is omega h dh. Diba? Okay? So, therefore, okay, omega h dA. Sorry, not dh. Okay? So, omega h dA. So, therefore, so by substituting this will be 6 omega. So, h dh. Diba? So, then solving for the force, that will be 6 omega. Constant yung omega natin kasi water lang to. Diba? So this will be integral so ng h dh. Diba? So ano yung limits of integration natin? Mula dito sa pinaka-surface where h is 0 hanggang sa pinaka-bottom ng plate natin. So where h is equal to 8 meters. So therefore this will be from 0 to 8. Okay? So then, so substitute omega. So this is kilonewton. Diba? So therefore SI unit yung gagamitin natin. So let's use 9.81. So this is kilonewton per cubic meter. Diba? So then multiplied by, so yung integration natin, okay? Pag in-integrate natin yan, so x dx lang, so from 0 to 8, so you will get 32. Diba? And this will be meters times meter. So this will be, ito meters din to. Diba? So kaya basically cubic meters na to. No? So again, meters to, meters to, meters to. So kaya may cubic meters pa tayo dyan. So cancel yung cubic meters, so kaya matitira sa atin ay kilo newton. Diba? So we have 32 times 9.81 times 6. Diba? So you will get 1,883.52 kilonewton. Diba? Okay, so therefore this is letter. Okay, so again, that's by integration. Diba? Pag without integration, so dapat alam niyo yung equation for the area. Rectangle lang naman yan, kaya area is base times height. Yung base ay 6 meter, yung height ay 8 meters. So therefore, the area is 48 square meter. Pangalawang kailangan natin is the location of the centroid. Pag rectangle, nasa pinakagitna lang yung centroid. Diba? So kaya ibig sabihin, so yung layo natin mula sa top, mula sa surface, is kalahati ng height. Yung height natin 8 meters, so kalahati niya is 4 meters. Diba? So therefore, so yung h-bar na gagamitin natin dito, itong h-bar na to, yung h-bar natin is layo ng centroid from the surface. So kaya 4 meters na yung gagamitin natin. So h-bar is 4 meters. Diba? So then solving, so for the force, so again we can use omega h-bar A. So this is 9.81. So this is kilonewton per cubic meter, diba? So multiplied by h bar. So ang h bar natin dito ay 4 meters, diba? And yung area natin so is 48 square meters. Cancel square meter, cancel yung meter, cancel yung cubic meter. So therefore we can have the force. Okay, so 9.81 times 4 times 48, diba? So we get 1,883. So this is 0.52 kilonewton. So pareho lang yung lalabas, diba? Without integration man siya or with integration, diba? Okay, so any questions para dito? Okay. So let's try another example, diba? So problem number 13. So this time we have a cylindrical tank, diba? So ito yung sinasabi ko sa inyo kanina, diba? Minsan, diba? So raw yung ginagamit sa mga libro, diba? Even though makikita natin yung unit is pounds per cubic feet, which is technically the weight divided by the volume, diba? So ibig sabihin itong given na to, this is already the specific weight. Okay? Nakuha ba? So hindi siya density. Diba? So kaya ingat kayo dyan sa mga problem natin. So pag raw yung givens or omega, no? Okay? Nakuha ba? So again, ang tignan nyo dyan is yung unit kung available. Diba? Pag yung unit is weight over the volume, ibig sabihin specific weight yung given. Diba? So pag naman ang nakalagay is mass per unit volume, so ibig sabihin that's the mass density. Diba? So kaya dito, papalitan ko na tong row na to, so papalitan ko na siya ng omega. Okay? Nakuha ba? So again, so para hindi tayo malito dun sa equation natin. Okay? So then dito, meron kang cylindrical tank, it's lying on its side. So ibig sabihin nakaganito yung cylinder natin dyan. Okay? So kaya half full siya, so ibig sabihin may laman tong kalahati. Okay? So ibig sabihin hanggang kalahati ng face, ng base natin, hanggang kalahati ng base natin, di ba, is meron is nakasubmerged dun sa oil. Okay? Nakuha ba? So ibig sabihin yung force natin is nararamdaman lang dun sa lower half ng circular base natin. Okay? Nakuha ba? Kaya pag i-drawing natin to, okay? So we can have a circular base, diba? Tapos nakalagay naman dyan, so this is half full. So ibig sabihin, so dun lang tayo sa lower half. Okay? So ito lang yung nakasubmerged dun sa fluid natin. Or in this case, yung fluid natin is oil. So ibig sabihin, so yan lang yung i-consider natin. Okay? Okay ba? So then, find the force exerted by the oil on one end of the tank. Diba? So again, so two ways to answer this problem. So ang una nating alam dito is that the diameter is 8 feet. So meaning the radius is 4 feet. No? Kalahati ng diameter, kalahati ng 8 is 4. So kaya 4 feet yan. Diba? Tapos nakasubmerge. Diba? Yung kalahati, yung semicircle lang. Okay? So let's consider, diba? So yung horizontal strip natin. So let's say we have this one. Okay, so this is our horizontal strip. Okay? So let's consider this horizontal strip. So una, yung layo natin from the surface. So again, so lagi natin itong dinedefine as h. So if we use a horizontal strip, diba? Yung thickness ng strip natin, diba? So s dh, diba? Kasi yung vertical distance natin ay h, so therefore yung change niya is dh, diba? And as for the width natin dito, so itong width na to, okay? So ang gagawin natin dyan is, hahatiin natin to sa dalawang parts. Okay? Nakuha ba? So then doon sa dalawang parts na yan, so tawagin natin to for example as x. Tawagin natin to as x. Diba? So kaya makikita natin, diba? So na yung total width natin so will be given by 2x. Okay? Nakuha ba? And remember that the distance from the center papunta dito sa isang point natin dun sa gilid. So this is just equal to the radius. So kaya dapat pareho lang siyang 4 feet. Diba? And again, mula dito hanggang dito, diba? So we know this length to be equal to h. Diba? So therefore, so we will form here a right triangle. Diba? So makakabuo kayo ng right triangle dito. Okay, so then we can use Pythagorean theorem. Diba? So by Pythagorean theorem, diba? So we know that, okay? So we have h squared plus x squared. So this is equal to, so we have 4 squared. Okay? Nakaba? Okay, so or, okay? So we can write yung h natin, diba? So as square root of, so 4 squared is 16, so minus x squared. Okay? Nakaba? So meron na tayong h, diba? So dun sa equation, okay? So as a function of x, diba? So now let's solve for, or baliktad ba dapat? Sige, balik na rin natin. No? Okay? So mukhang x yung kailangan ko palang palitan. So therefore, x will be square root of 16 minus h squared. No? So then solving for the differential area, so again, we know the differential area to be 2x. multiplied by dh. Diba? So kaya this will be 2 square root of 16 minus h squared dh. Okay? So we have the differential area. So for the differential force, that is simply omega h dh dA. Diba? So then this will be omega. So then times 2 times h. Okay? So we have omega h, no? So multiplied by 2 square root of 16 minus h squared dh. Diba? So then, okay, so to solve the force, we can factor out the constant, that's 2 omega. So then this will be integral, so ng h square root of 16 minus h squared dh, diba? So yung h natin, so we'll start from h is equal to 0, yung pinaka-surface, hanggang sa bottommost part, diba? That's h is equal to the radius, that's 4 feet, diba? So kaya from 0 to 4. Okay? So ano yung omega natin? Omega is 50 or 75. So omega natin ay 75. Okay, so this is pounds per cubic feet, 'di ba? So then yung masosolve natin dito, remember yung 2x natin dito, so itong 2x na to, saka itong dh na to parehong feet to. Kasi they are measure of distance. And feet yung ginamit sa problem, so therefore this is in feet. So meaning this is square feet, this is cubic feet, 'di ba? So kaya lalabas sa integral natin will be in cubic feet, 'di ba? So 2 square root of 16 minus h squared. Okay. So then, okay, so then dh, diba? So then this will be from 0 to 4. Okay. Okay. So, sabang hinihintay natin yung lalabas sa integral na to. So, kasi medyo matagal siya since may square root. No? Okay. So, while we wait, diba? So, let's solve for the, let's use the other solution. So, again, sa isang solution natin, kailangan natin ng area, diba? So, of the semicircle. Diba? So, again, so the area of the semicircle is kalahati ng area ng circle. So, 1/2 pi r squared. So, that's 1/2 pi. So, ang radius dito ay 4 feet. So this quantity squared, so you will get 8 pi. So this will be in square feet. No. Okay, so this will be our area. Okay, nakuha ba? So now, okay, so lumabas na 64 over 3. Okay, so this is 64 over 3. So again, so this will be in cubic feet. No? So kaya magka-cancel to. Okay. So then we have 2 times 75, so times 64 over 3. Okay. So we have 3,200. So this will be in pounds. Okay. Nakuha ba? So any questions para dito? So we have letter B. Okay. So again, so for another solution natin, so this is yung area. Diba? So then ang pangalawang kailangan natin is the location of the centroid. So yung tatandaan natin pagdating sa isang semicircle, so let's say we are given this semicircle. So yung centroid natin, diba, is syempre nasa axis of symmetry. So pag hinati natin ito sa dalawa, so somewhere dyan. Tapos, okay, so nandito siya. Such that yung layo natin, so mula dun sa base, so is given by 4 times the radius divided by 3 pi. Diba? So kaya dito sa figure natin, so pwede nating sabihin na yung centroid natin is nandun sa gitna, somewhere dito, di ba? Tapos yung layo niya from the base, so basically ito na yung h bar natin, di ba? So this is 4r over 3 pi, di ba? So kaya pag sinolve natin to, diba? So we have h bar, so this is equal to, so we have 4r over 3 pi. Okay, nakuha ba? So again, radius natin ay 4 feet. So again, 4 feet. So this is divided by 3 pi. Okay? So pag sinolve natin to, so you will get, so 4 times 4, so divided by 3 pi. Okay? So then you will get, so 1.698. So gawin ko na lang tong 16 over 3 pi. So then this will be in feet. Diba? So then solving for the force, so again, that is given by omega H bar times A. So this is 75. So this is pounds per cubic feet, no? So then multiplied by 16 over 3 pi feet, diba? So then multiplied by, so area, so is 8 pi square feet, no? So kaya cancel yung cubic feet, cancel yung pi. So then solving this, so 75 times 16 over 3 times 8, diba? So you will also get 3,200 pounds. Okay, so any questions? Diba? So para dito. Okay, so again, so gaya ng sabi ko sa inyo kanina, so again, yung omega, so is specific weight, yung rho is mass density, diba? Pero gaya sabi ko kanina, so sa ibang libro kasi, yung rho, diba, especially for English unit, nagiging mass dense, nagiging pounds, diba? So yung pounds kasi sa unit of weight, diba? So kaya it's better for us pag ang gamitin natin is omega, no? Kasi yung pounds is a unit of force, diba? So not a unit of mass. Ang mass natin sa English unit is slugs. Okay? Naka ba? So then, so kopyahin niyo muna, no?
Recording stopped.
Submit lang.
Confrère allemand, le docteur Müller.
Sehr angenehm.
J'ai pris la liberté de promettre au docteur Müller que vous lui donneriez la recette de votre soufflé à la pomme de terre.
Ja, s'il vous plaît.
Mais vous savez que c'est un secret professionnel.
Oh, Charlie, entre nous.
Bon, alors, pour vous, monsieur le commissaire divisionnaire. Alors voilà. Vous prenez 1 Kilogramm Kartoffeln.
Für wie viele Personen?
Ça dépend. Pour 6 personnes normales ou alors pour une personne anormale, une grosse personne. Alors, 1 Kilogramm Kartoffeln, 1 Liter Milch, 3 Eier, 90 Gramm Butter, Salz und Muskatnuss. Muskatnuss. Je répète, Herr Müller, ich wiederhole. 1 Kilogramm Kartoffeln, 1 Liter Milch, 3 Eier, 90 Gramm Butter, Salz und Muskatnuss! Muskatnuss, Herr Müller! Signor Riganti, Monsieur le Commissaire, haben Sie verstanden, Herr Müller?
Sorry about that, no? So again, so yan yung fluid force natin sa solution. Okay?
Recording in progress.
So kaya nung ginawa natin doon sa dalawang problems, so again, there's two solutions, diba? So na pwede nyo gawin. So with integration or without integration. So kahit ano naman gamitin nyo dyan, diba? So pareho lang naman madali silang gamitin. So basta naiintindihan nyo yung concept. No? Okay? So kasi yung integration, diba? So at least wala kayong kailangan memoryahin. Diba? So yung solution natin, so lies, naglalay lang siya dun sa figure natin. Diba? So basically area lang siya ng rectangle. Diba? So base times height. So tapos concept lang siya ng force, diba? So which is omega HDA. So we just follow that, diba? So then, so kahit ano pa man ang ibigay sa atin na figure, we can solve. Diba? Okay? So pero yung sa without integration naman natin, so again, this is limited only to figures kung saan memoryado natin yung direct formula sa area saka direct formula sa H bar. Okay? Nakuha ba? So actually may mga direct formula din tong fluid force. Depende sa shape na kino-consider natin. No? So pero kayo na yung bahala kung gusto niyo aralin yung part na yan. So you can derive naman, diba? So using the direct formula. For example dito, so ipasok niyo to dun sa area, diba? Tapos ipasok niyo to dun sa H bar. So then then we have the omega, diba? So which is just a constant, okay? So then tignan niyo kung ano yung magiging form ng equation, diba? So pero syempre limited lang siya dun sa mga figure, so with the diameter at the surface, tapos semicircular shape, diba? So pero again, so for different shapes, pwede nyo i-derive yung iba't ibang formula na pwedeng gamitin. Diba? So pero kayo na yung bahala kung gusto nyo gawin. Diba? Okay? So ang importante, so alam nyo paano yung paraan ng pag-solve. Diba? Okay? So any questions? Diba? So again, so yung pinakamagandang gawin pa rin dito is to memorize the area and the location of the centroid for different figures, especially conic sections, kasi sila yung mga madadalas lumabas, saka yung mga part nila. For example, mga semi saka mga quarter, diba? So kasi lumalabas din yan sa board exam. So then we have triangles. So then we have rectangles, diba? Yun lang naman yung mga madadalas lumabas sa board exam. So pag hindi ganun yung lumabas sa board, so na shape, so then use integration. Diba? So ay maganda na alam nyo pa rin pareho. Okay? So yan. So nung review ako sa board dati, sa nung nagbo-board exam ako, pag naka-encounter ako ng mga gantong problem, so tinatry ko na lang parehong solution. Diba? So para at least sigurado. Kasi pag pareho yung lumabas sa sagot, ibig sabihin tama talaga yung solution natin. No? Okay? So let's proceed to the next topic, diba? So which is work done by a spring, diba? Yung tatandaan nyo lang pagdating sa work done, diba? So yung work done natin so is basically, diba? So force, diba? So dot product with a displacement, okay? So which the displacement S. Okay? So kaya in terms of magnitude, this is the magnitude of the force times the displacement, so times cosine of theta, diba? So yung theta is the angle between the force and the displacement. So let's say ito yung displacement natin, tapos yung force natin is directed in this direction, diba? So then ito yung angle theta natin. Okay? Okay ba? So pagdating sa isang spring, diba? So you can imagine na for example, okay? So again, so let's say ito yung spring natin, okay? So tapos let's say meron ka ditong okay? So let's say meron ka ditong object, okay? Okay ba? So then so yung object, so let's say yung object natin gumagalaw, diba? So we have a displacement S here, okay? Okay ba? So then so we can imagine so na habang gumagalaw dito yung object natin, so then the force exerted by the spring, diba? So can be in this direction. Pwede siyang dito sa direction na to, diba? So which is anti-parallel with the displacement. So pwede rin naman siyang in this direction, diba? So kasi pag yung spring natin is initially compressed, diba? So then ibig sabihin itutulak niya tong object natin, diba? So pag naman siya initially expanded, diba? So then so habang lumalayo to, diba? So then hinihila niya naman pabalik yung object natin. So therefore, so yung force natin is either 0 degree or 180 degree yung angle natin for the displacement, diba? So pero kadalasan ang kino-consider natin dito is yung positive component, diba? So which means so we are considering this force here, diba? Okay? So kino-consider na lang natin siya depende dun sa position ng object natin. So with respect to the spring. So pag pinasok natin dun sa equation ng work, diba? So basically yung work natin, diba? So will be given by, okay? So the differential work, diba? So will be given by, so this is so this will be given by F, diba? So then this will be dx or ds, okay? Nakuha ba? So again, so this will be our differential work, no? So if we consider an infinitesimal increase, diba? So or yung infinitesimal motion, so nung object natin, for example, in that direction or in this direction, diba? So remember na yung force natin, so for a given spring is given by K multiplied by X minus X sub 0, diba? So in this case, since S yung ginamit ko, diba? So then this will be S minus S sub 0. Okay? Diba? So or palitan na lang natin siguro ng variable, diba? Since this is in the horizontal direction, so gawin natin tong X. Diba? So then this will be X, so then this will be X sub 0. Okay? So then this will become dx, no? So para pareho ng mga nasa libro. Okay? Nakuha ba? So again, so the idea is pag nag-move to ng infinitesimal amount, diba? So let's say, so this moved, diba? So by an amount dx. Okay? Nakuha ba? So then this is the amount of force, diba? So na i-exert ng spring natin, diba? So kaya this will be given by, so we have a constant K. So ito yung spring constant natin. So kaya so ito dapat napag-aralan nyo ito nung sa mechanics nyo, diba? So most likely naman, so nag-mechanics kayo dyan sa school nyo, diba? So again, so this is K, so times X minus X sub 0. Yung X sub 0 natin dito is the original length, okay? So again, this is the original length, okay? Nakabasa nung spring natin, okay? Nakabasa yung X naman is yung final length, diba? So of the spring. Okay, so kaya makikita natin that this is negative, diba? So kung nakakompress yung spring natin, tapos siya naman ay positive, pag naka-expand yung spring natin. Okay? Okay ba? So itong x minus x sub 0 natin. Diba? So this is less than the original length pag naka-compress, greater than the original length pag naka-expand. Diba? So kaya yun yung lalabas. Diba? So then this is multiplied by dx. So yun yung magiging differential work. So kapag in-add up natin yung mga differential work nito, diba? So again, so during its process ng pag-move, diba? So you will get that the work done, so will just be equal to, so constant lang yan. So then we have integral, so ng x minus x sub 0 dx, diba? So again, so over its entire motion. So for example, from position 1 papunta sa position 2, diba? So pag ginawa natin yan, so this will just be k multiplied by, so x minus x sub 0, so by power rule, squared divided by 2. Diba? Tapos ang derivative naman yung nasa loob is just 1. So kaya hindi lang siya lalabas dun sa equation natin. So this is evaluated from x1 to x2. So therefore, the work done for a spring is 1/2 k multiplied by, so this is x2 minus x0 quantity squared minus, so this is x1, okay, minus x0, so this is quantity squared, diba? So or pwede mo siyang isipin as 1/2 k multiplied by, so this is delta x2 squared minus delta x1 squared, no? So kaya ang tinitingnan natin dito is yung change in length, diba? So nung spring natin, so from its original length, diba? So yung hindi naka-compress, hindi naka-elongate, diba? So kaya pag work done by a spring, direct formula lang yung gagamitin natin, diba? So although yung concept na ginamit natin dito is also integration. Okay? So try natin to sa example. So if a force of 400 newtons so stretches 3 meters by 0.5 meter. So remember, delta x na to. Diba? So ang equation natin for the force, diba? So again, this is given by k multiplied by x minus x sub 0. So again, so ito ay delta x na mismo. Diba? So which means, so yung delta x natin ay yung spring constant natin, diba? So it's just equal to yung force na in-exert natin, so para sa elongation na delta x. So this is 400 Newton divided by 0.5 meters. Okay? So you will get that this is 800 Newton per meter. Diba? So then find the work done in stretching it from 3 meters to 5 meters. Diba? So again, direct formula natin for the work done, so it's 1/2 k multiplied by, so we have x2 minus x sub 0 squared minus, so we have x1 minus x sub 0 squared. So again, direct formula. So we have 1/2 times 800 Newton per meter multiplied by, so again, ang x2 natin dito ay 5 meters minus original length 3 meter squared minus, so we have 3 meters, original length is 3 meters squared. So then this is 0. So kaya lalabas dito ay equal lang sa, so we have 3,200. So we have 1,600. So this is in square meters. Diba? So cancel yung meter. So Newton meter or joules. Convert natin sa kilojoule. So we have 1 kilojoule for every 1,000 or 10 to the 3 joules. Diba? So kaya tandaan nyo lang dito yung direct formula natin. So we have 1.6 kilojoule. Okay? Naka ba? So actually lumalabas din sa ESAS. So yung ganitong uri ng problem. Okay? So siguro sa ibang courses is yung equivalent nyo ng engineering sciences. Diba? So lumalabas yung ganyang uri ng problem. So I think GIAS ata siya doon sa ECE. No? Okay? So any questions? No? Okay? So tandaan nyo na equation na to. So pag work done by a spring, so ito naman pag force. Diba? So yung force ng spring natin. Okay? So next is the work done by a pump. No? Sa work done by a pump naman, so meron din to kinalaman sa pressure. Diba? Okay? So kasi yung work done natin, diba? So gaya ng kanina, diba? So na ginamit natin. So work done is just force. Diba? So then multiplied by the displacement. Okay? Okay ba? So again, so this is F dot S. Diba? So equivalent sa F, so times S cosine of theta. Diba? So pero pagdating naman sa pagpa-pump ng water, so imagine natin, so we have, let's say, a cylinder. Okay? So let's say yung water. So yung water, diba, is pinapump natin, for example, pataas, diba? So kaya yung force na ina-exert natin dito ay pataas, diba? So tapos yung displacement ng water natin is also pataas. So therefore, the angle, diba, so between them is 0. So kaya cosine 0 din yung lalabas dito. So kaya this will just be equal to 1. Diba? So again, para sa isang pump, diba? Kaya force times displacement lang yung lalabas. Okay? Okay ba? So saan ba equal yung force natin dito? So again, yung force natin dito is just equivalent to pressure, diba? So multiplied by the area. Okay? So yung area natin dyan is yung cross-sectional area, diba? So nang pinapump natin pataas. Okay? Okay ba? So then this is multiplied by, so yung S naman natin dito is simply dH. Diba? So again, so let's say we have the thickness here, dH, diba? So para dun sa volume, diba? So na gusto nating i-pump pataas. Diba? So itong volume na to, so for example, we have this volume here. Okay, so itong differential volume na to, ipapump natin pataas. So that will be dH, diba? Pero since part lang siya ng volume na pinapump natin, so dW pa lang yan, diba? And remember na yung ADH na to, so this is cross-sectional area times dH, that is just the differential volume ng pinapump natin, diba? So meaning, this is pressure, so multiplied by dV. So again, alam naman natin yung pressure is omega H, diba? So omega H dV. So then this is our dW. So therefore, the work done is just the integral over the volume, so ng omega H dV. So makikita natin pareho lang siya sa fluid force. Ang pinagkaiba nga lang niya is volume yung ginagamit natin instead of the area. Diba? So then if omega is constant, diba? So then pwede natin siyang ilabas ng equation. So then this will be omega, so then integral ng H dV. So then this will be given by omega, so H bar times the volume V. No? So this is our direct formula. So although dun sa problem na example natin, itong integration lang yung gagamitin natin. Okay? Wala kasi tayong direct formula for the centroid of a frustum. So although pwede natin siyang isolve considering a cone minus another cone, diba? So pero medyo hahaba yung solution natin, diba? So kaya doon na lang tayo sa integration solution. Okay? Pero pag alam niyo yung direct formula for the centroid of volume, saka yung volume, diba? So ng given a solid, so pwede niyo gamitin, diba? So itong equation na to para wala lang integration. Okay? So pero again, so pag hindi niyo naman alam yung formulas, diba? So then, so pwede natin gamitin yung integration. So actually dito integration yung usual kong ginagamit. Diba? So nung nagre-review ako, so kasi parang hindi worth it kasi yung memoryahin yung centroid ng volumes, no? So kasi bihira naman siya lumabas sa board exam. So at least sa REE, no? Bihira ako makakita ng problem na three-dimensional, diba? So pagdating sa board examination, especially pagdating sa integration. Okay? Kung meron mang lumalabas sa board exam, usually nasa less than 2% or less than 3%, no? Okay? So kaya mababa lang yung chance, okay? So kaya mas pinipili ko na yung way na konti lang yung kailangan kong memoryahin, so pero kaya ko pa rin i-solve yung problem in case na kailanganin, di ba? Okay? So yan. Okay, so let's try integration, di ba? So for the next problem, okay? So okay, so yung nakalagay dito kasi na shape natin dito sa frustum, no? Frustum of a right circular cone. Okay, okay ba? So yun yung reason kaya hindi na natin gagamitin dito yung without integration na solution. So unlike kasi dun sa fluid force natin kanina, isang direct formula lang meron na tayo. Sa frustum kasi wala siyang direct formula. Although pwede kayo mag-derive ng sarili nyong formula, so pero I doubt magiging simple lang yung equation. No? So kasi kung simple lang yung equation ng centroid, ng frustum, ng right circular cone, diba? So then, madali sana natin makikita yun sa net. No? Okay? Okay? So pero dati sinerch ko na yan, so pero walang lumalabas. Diba? So ibig sabihin, kung meron mang direct formula, so hindi siya ganoon kaganda yung itsura. No? Possibly may mga square root na makikita dun sa equation. So kaya hindi siya worth it na memoryahin. Diba? So although again, gaya na sabi ko kanina, pwede natin siyang isolve. Kasi frustum ng cone is just a cone minus a smaller cone. Diba? Okay? So pero anyway, diba? So let's use the integration formula. So first, diba? So we have a frustum shaped na container, diba? Or tank in this problem. So again, pag sinabi nating frustum, so imagine nyo lang meron kayong circular cone, tapos tinanggal nyo yung top na part. such that yung base na, yung dalawang base ng frustum natin are parallel to each other. Diba? So basically, so let's say ito yung lateral side so ng frustum natin. So again, this is originally a cone. Okay? So imagine nyo, so you have a cone. Okay? So yan. So we have a circular base. Okay? So circular base, no? So tapos tinanggal natin yung top na part. So therefore, we also have a circular top here, diba? So again, so dapat parallel yung dalawang base natin, no? So kaya ito yung lalabas na frustum natin. Okay? So this is a frustum of a cone, diba? Tapos yung gusto natin mangyari dito is ipapump natin yung oil to a height of 10 feet above the tank, diba? So then you can imagine, diba? So na meron ka ditong, let's say we have this pipe, okay? And yung gusto natin mangyari dito is may-pump out natin dito yung oil natin. Okay? Nakuha ba? So ganyan yung gusto natin mangyari dito sa problem. No? So gusto natin mangyari is if we assume, diba, so that, okay, so yung frustum ng cone natin, yung container natin or yung tank natin is initially full. So then gaano kalaking work, diba, so yung kailangan natin i-exert, ay so para lang mailabas natin yung lahat ng oil dun sa frustum natin. No? Okay? So even though wala nakalagay dito, ayun pala nakalagay, filled with oil. So ibig sabihin, we will assume na puno to ng oil. Diba? So tapos ipapump natin yung buong volume niya to a height of 10 feet above the tank. No? So again, ito yung point of exit natin. Okay? So this is the point of exit. Okay? Nakuha ba? So kung yan yung point of exit natin, sabihin ito yung i-assume natin na reference. So yung height natin, yung H natin, so will be measured mula dito sa point of exit na to. Okay, nakuha ba? So again, so mula dito sa top ng vase or sa top ng container natin or the top of the tank, papunta sa point of exit, sabi sa problem that is 10 feet. Diba? So tapos, mula dito sa base ng frustum natin, so papunta doon sa top ng frustum natin, sabi dyan, the height of the tank is 10 feet. So therefore, this is also 10 feet. Okay? So then the radius, diba? So of the base is 6 feet. So ay mula dito, so hanggang dito. So again, that's the base, that is 6 feet. So then mula naman sa top radius naman natin ay 4 feet. So mula dito hanggang dito. So this is 4 feet naman. Okay? Okay ba? So let's try to solve this problem. Diba? So syempre one way to solve this is by analyzing this or by using analytic geometry. Diba? So by using graphing. Diba? So our Cartesian plane. So we consider this as our y-axis. So yung dumadaan sa center or the axis of the frustum. So let's consider this as our y-axis. So for our x-axis naman, so let's consider the base. Okay? So we will consider this base. This is our x-axis. So then this is our origin. Diba? So then mula dito, so pwede natin kunin tong point na to. Diba? Kasi yung layo niya from the axis, from the y-axis is 4 feet. So the x-coordinate is 4. Tapos yung layo niya from the x-axis is 10 feet. So therefore, this will be 10. Diba? So tapos itong point naman na to, so again, nasa x-axis siya, that's y is equal to 0. And yung layo niya from the y-axis ay 6 feet. So this is 6. So therefore, we have 2 points. So we can get the equation of this line. So itong line dun sa side ng frustum natin. No, so tawagin natin to as line L. Diba? So for line L, okay, so again, using the 2-point form, diba? So ang 2-point form natin, so pag-create ng line is y minus y1 is equal to y2 minus y1, so over x2 minus x1. So this is multiplied by x minus x1. No? Okay, so then, so this is y minus, again, ang y1 natin, so let's consider this as x1, y1. Let's consider this as x2, y2. So y1 is 0. Ang y2 natin is 10, ang y1 natin ay 0, x2 natin ay 4, ang x1 natin ay 6, multiplied by x minus x1, so x minus 6. So we have y is equal to, so 10 divided by, this is negative 2. Okay, so therefore that is negative 5, so this is negative 5x. So then this will be plus 30. Okay, so yun yung equation ng y natin. And remember, yung y natin, diba, is yung layo. Okay, so mula sa x-axis natin, so no point natin doon sa line. Diba? And again, so this line extends, diba? So even, diba? So above the frustum. Diba? Okay? So again, yung equation ng line natin na to, so this extends even above the frustum. Diba? Okay, so again, nag-extend yun dyan. Okay? So kaya pwede natin gamitin yan siya dito sa any line na to. Diba? So pero more importantly, so pwede natin siyang gamitin sa mismong line. Diba? Okay? So any questions? Diba? So far? So dun sa solution natin. Okay? Okay ba? So ano yung next step natin? So let's consider a horizontal disk. Diba? So again, so since this is a frustum of a cone, alam natin yung mga cross-section nito parallel or perpendicular, perpendicular so dun sa axis ng frustum natin, so our circular discs, di ba? So mga circular disc lang yung makikita natin dito. So let's say we have certain thickness here. Okay? Okay ba? So then makikita natin dito na yung thickness natin, di ba, is along the y-axis. Kaya alam natin yung thickness natin, so will just be dy. Okay? Okay ba? So then yung layo ng disk na to. So again, remember, dun sa equation natin dito, yung h natin dito, so ito yung h natin, di ba? So again, yung h natin is mula dun sa volume na dadalhin natin dun sa taas, okay? Nakuha ba? So papunta dun sa point of exit. Okay, nakuha ba? So let's say ito yung point of exit natin. So point of exit, diba? So therefore, dito yung point of exit natin is ito. So 10 feet above the top of the tank, diba? So kaya mula dito, okay, hanggang dito sa define natin na dV, na differential volume, ito yung i-consider natin na H. Okay? Nakuha ba? So we will consider this as our H. Okay? So and remember, diba? So itong point na to, so dun sa cross section natin is a part of the line na sinolve natin as this one. So therefore, this point should satisfy this equation such that yung layo niya from the x-axis, yun yung naka-define as y. So therefore, ito yung h, ito yung y. So h plus y is equal to 10 plus 10, diba? Kaya solving for h, makukuha natin yung h natin is simply 20 minus y, no? So 10 plus 10 minus y. So yun yung h natin. Okay, okay ba? So any questions dito sa nakuha nating h? So ito yung isa natin kailangan. The value of h, diba? So in terms of y. Okay? So then, so again yung dh natin, so is simply equal to dy. Diba? So yung dh natin pareho lang nung dy. So orientation. Diba? So pangalawa, diba? So ano pa kailangan natin para makuha natin yung work done? So again, equation natin is omega h dV, diba? So kaya next natin isosolve is itong dV, diba? The differential volume. But again, remember that this is just a disk. So therefore, yung differential volume natin ay simply equal sa area ng base multiplied by dH, diba? Pero saan equal yung area ng base? Ang area ng base natin is just pi r squared. So where this is the radius r, diba? But as you can see, yung r natin is yung layo lang ng point natin mula sa y-axis. Therefore, this is the x-coordinate. Diba? So kaya ibig sabihin, so this will just be given by pi x squared dy. Diba? Kasi yung dh natin is equal sa dy. Diba? So now, saan equal yung x? Okay? So kasi dy to, so kaya dapat in terms of y to. Diba? So again, from this equation, okay? So mula sa equation na to, we can solve for x. Diba? So this will be equivalent to, so we have 30 minus y. So this is divided by 5. Okay? Okay ba? So then, substituting here, so you will get pi. So then this is multiplied by 30 minus y. So divided by 5. So this quantity squared. So then this will be dy. So again, so this is our dV. So kompleto na. Meron na tayong omega. So again, sabi dyan, 50 pounds per cubic foot. So kaya meron na tayong omega dito. So again, this is 50 pounds per cubic foot. No? Okay, so tapos meron na tayong h. Meron na tayong dV. So we can now solve the work done. No? Okay? So solving for the work done. So again, work done is simply equal to, so omega h dV. Diba? So again, integral lang nito over the whole volume. So then this will be equal to, so this is equal to integral. Diba? So, so integral. Diba? So nung omega natin, so again, omega is 50 pounds. Okay? So, ilabas ko na lang muna siya ng integral. Or start tayo sa DW. So, para hindi tayo malito. Okay? So, again, so start ako sa DW. So, again, so this is given by, so we have omega H multiplied by dV. Diba? So, this will be given by, okay? So, omega, so yung H natin is 20 minus Y. Okay? So, then, so yung dV natin, so is pi multiplied by, so we have 30 minus Y, so divided by 5. So, this quantity squared. So, multiplied by dy. Diba? So, makikita natin, may integrate na natin to. Diba? So, then the work done, so will be given by, so factor out ko yung mga constant natin. Diba? Okay? Okay? So, again, factor out ko yung mga constant natin. Diba? So, we have pi omega. Diba? So, then this is divided by 5 squared is 25. So, that's also constant. So, then this will be integral. Diba? So, of. So, ang matitira sa atin is yung 20 minus y. Diba? So, then this is multiplied by. So, we have 30 minus y. So, this quantity squared. No? So, tapos meron tayo ditong dy. Okay? Okay ba? So, yan yung mangyayari. Ano yung limits of integration natin? Yung laman lang ng frustum. Diba? So, kaya that's from the bottommost part, that's y is equal to 0, hanggang sa topmost part, that's y is equal to 10. So, therefore, this is from 0 to 10. Okay? Okay ba? So, kaya lalabas sa atin dito na work done. Diba? So, will be given by. Okay? So, let me substitute yung omega. So, again, yung omega natin is the specific weight. Diba? So, again, yung specific weight natin is defined as the weight over the volume. Kaya dito makikita natin yung pounds, diba? So, per cubic foot. So, that's weight over the volume. Kaya alam natin itong given na 50 dito is omega. Okay? Naka ba? So, again, basta pounds per cubic foot or in the form of Newton per cubic meter. Diba? So, basta weight over volume yung unit niya. So, again, that's omega. That's specific weight. Diba? So, yun yung kino-consider natin. Okay? So, this is pi over 25. No? So, times omega. So, again, ano yung omega natin? 50. Diba? So, then multiplied by, okay? So, yung, ano natin? So, itong laman ng integration natin. Okay? So, alam ko may i-convert pa tayong unit dito. Okay? Okay. So, dito ko na lang ituloy. No? So, kasi hindi na kasya dyan. Okay? So, we have that. Work done. So, will be pi. So, times 50. So, remember, this is pounds per cubic feet. So, base dun sa given. So, this is divided by 25. So, then multiplied by yung lalabas sa integration natin. So, remember na yung integration natin, diba, is galing sa equation na HdV. Diba? So, HdV is feet multiplied by cubic feet. Diba? So, kaya ibig sabihin that's feet to the 4th power. Diba? So, kaya feet to the 4th power yung lalabas na unit natin sa integration. Okay? So, again, so integral, so ng 20 minus y. So, times 30 minus y, quantity squared. So, then this will be from 0 to 10. Okay? So, kaya lalabas dito ay 297,000. So, this is 500 divided by 3. So, again, so this will be feet to the 4th power. So, kaya magka-cancel dito yung cubic feet. So, this will be in pound foot. Diba? Pero yung mapapansin natin dito, so yung lumalabas dito na work done, diba? So, will be, so times pi times 50 divided by 25. So, you will get 595,000 pi. Okay? So, then this will be divided by 3. So, again, so this will be in foot pounds. Okay? Pero makikita natin wala yan sa choices. Diba? So, kasi, yung nasa choices natin is iba yung unit. Okay? Nakuha ba? Isa sa mga common unit natin pagdating sa work done, especially pagdating sa mga large scale na mga project natin, so is foot ton. Diba? So, kaya ito yung ginamit dun sa problem natin. Diba? So, but this is not the ordinary ton na alam natin. So, yung foot ton na ginamit dito is yung tinatawag natin as the English ton. Kumbaga siya yung ton equivalent sa English unit. Diba? And yung English ton natin, diba? So, 1 English ton, okay, is equivalent to 2,000, okay, so pounds. Okay, nakaba? Yung metric ton kasi natin 1,000 kilogram, di ba? So ibig sabihin that is around 2,200 pounds. Okay? So yung English 10 natin exactly 2,000 pounds. So pag ginamit natin siya dito, so again, so dito ko na lang idugtong. So again, so yung work natin is 595,000. So pi, so this is divided by 3. So then this will be in foot pounds. Okay? So multiply lang natin ito ng 1 ton for every 2,000 pounds. So para mag-cancel yung pounds, so again, so this will be in foot ton. Diba? So pag ginawa natin yan, so mapapalabas natin yung nasa choices, diba? Which is 312 foot ton. Okay? So therefore, the answer is letter B. Okay? So any questions para dito? Okay? Questions? Okay, okay ba? So again, so yun yung lecture natin sa integral calculus. Okay? Okay ba? So then, so wala na kayong questions. So let's have a short break, no? 15 minutes lang. So let's continue by 10:35 ulit. Okay, okay ba? So 15 minutes break. Okay?
Recording
Okay.
stopped.
So yung next lecture natin will be differential equation. Okay? Okay? So yan. Okay, so again, so may clear lang naman yung sa differential equation. So yung mahirap lang kasi doon is yung sa mga word problems natin. Okay? So tapos, matatapos natin yun mamayang hapon. So then, diretso tayo ng advanced math then province stat. So yung advanced math saka province stat naman mabilis lang. So kasi karamihan sa kanila mga direct formulas lang yung ginagawa. No? So yung mahirap kasi talaga sa calculus is analysis. No? So kagaya nito, diba? So again, yung concept ng paghahati-hati, diba? So nung figure natin into differential figures. Okay? So yun yung nagpahirap sa integral calculus talaga. No? Okay? So any questions? Diba? So kung wala kayong questions, again, so let's have a short break. No?
Recording in progress.
Okay? So, continue natin, no? So, tapos na tayo sa integral calculus. So, pupunta tayo sa more applications, diba? So, ng integral calculus natin, diba? So, which is on differential equation, okay? So, again, yung mahirap na part, diba? Yung mahirap na part dun sa differential equation, okay? So, is yung setup, okay? Nakuha ba? So, kasi dito, again, so parang sa integral calculus na we set up the equation, diba? So, again, so using yung mga concepts natin, diba? So, such as rates, diba? Isa yun sa mga kino-consider natin sa differential equation, okay? So then, pag na-set up na natin yung equation, saka natin isa-solve yung differential equation. So which is focus more on integration. No? Okay? So pero yung pagsasolve naman natin ng differential equation, so madali lang siya basta makakuha kaagad natin yung form. Okay? So kaya ang una natin chine-check sa differential equation is the form na given sa atin. So ano ba yung order ng differential equation? So ano yung degree? Diba? So ano yung mga pwede natin gawin para madali natin siyang masolve. No? Okay? So yun yung tatandaan natin pagdating sa differential equations natin. Okay? So start natin. Okay? So let's discuss, diba? So yung order and degree, diba? So of the differential equation first. So okay, so importante na alam nyo to. So kasi isa to sa mga chine-check natin so bago tayo nagsosolve ng differential equation. No? Okay? So this should be raised to 2. No? So fix ko lang. So again, so even though sa board exam, so common yung mga ganyan na troubleshooting. Diba? Okay, so yung mga exponent minsan bumababa. Diba? Okay? So kaya dapat sanay na rin kayo sa mga ganyang instances. No? Okay, so let's discuss the order and degree of a differential equation. So yung tatandaan lang natin, pag sinabi natin order, di ba? So that is the highest order derivative. No? So nakukuha natin sa dun sa differential equation natin. Okay? Nakuha ba? So kaya for example dito, makikita natin that we have a third order derivative. Diba? So this is a third order derivative kasi siya ay third derivative. Diba? So ito ay second order derivative. Diba? Second order. So ito ay first order derivative. Diba? Okay? So tapos ito naman, so walang derivative dito. So therefore, so ano lang siya? Kumbaga, function lang siya. Diba? So ibig sabihin para siyang zeroth order derivative. No? So dito makikita natin that the order, diba? So dito sa problem na to, so yung order natin is equal to 3 kasi siya yung pinakamataas. Diba? So kaya sa choices natin, so hindi na pwede yung letter B, hindi na pwede yung letter D. So kasi ito lang yung merong third order na nakalagay. Diba? So and pag sinabi nating degree, so kung familiar kayo sa term na degree sa polynomial, this is the exponent. Diba? So therefore, pag sinabi natin degree, so ito yung power. Diba? So of, okay, so the highest order derivative. No? So ganito yung tawagin na lang natin as HOD. Okay? So power ng highest order derivative. So kaya hindi natin kailangan tignan yung power or the exponent, 'di ba? So nung iba nating order derivative, ang importante lang sa atin is the highest order derivative, 'di ba? So kaya dito, makikita natin this is the highest order derivative and wala siyang exponent. Therefore, yung degree niya is 1, 'di ba? So ibig sabihin, for this problem, so yung degree natin ay 1, 'di ba? So kaya yung sagot natin dito is 3, 1. Okay? Nakuha ba? So yun yung tinatawag natin na order and degree of a differential equation. Diba? So pero bago kayo kumuha ng order sa degree or bago kayo kumuha ng degree, kailangan nyo munang i-simplify yung differential equation. Diba? So unang-una, diba? So dapat yung differential equation natin so is walang fractional exponent. Okay? Nakuha ba? Walang mga derivative sa loob ng isang function. So for example, sine of y prime, 'di ba? So dapat walang mga ganito. Okay? So kumbaga dapat parang para lang siyang polynomial, 'di ba? Yung idea, 'di ba? So kasi polynomial bawal kang magkaroon ng fractional exponent, bawal ang negative exponent, 'di ba? So bawal na yung variable mo nasa loob ng isang function. So parang ganun din, 'di ba? Yung idea natin sa pagkuha ng order and degree ng polynomial, no? Okay? So pag yung mga derivative natin, 'di ba, is merong mga fractional exponent and the like, 'di ba? Tapos hindi natin siya ma-eliminate, 'di ba? Yung mga fractional exponent, 'di ba? So then sinasabi natin na wala siyang degree, 'di ba? So the differential equation does not have a degree, 'di ba? So again, that's the idea. Okay? So yeah. So pero again, so kakailanganin niyo lang naman to so para malaman niyo kung ano yung magandang gawing solution dun sa isang given na problem, no? Okay? Okay? So let's proceed to the next topic, no? Okay? So ang una nating focus, 'di ba, is yung pagso-solve ng first order differential equation. Okay? Pag first order differential equation, so ibig sabihin ang pinakamalaking derivative na makikita natin sa equation is a first derivative, 'di ba? And if we simplify a first order differential equation, magkakaroon lang tayo ng ganito, 'di ba? So you will get a form of, so we have f of xy, so which is multiplied by dx. So plus another function. So say this is f1. Okay? So then we have another function. So f2 of xy, diba? So then multiplied by dy. So then this is equal to 0. Diba? So this is a first order differential equation. Or parang ito yung kanyang general form. Diba? So notice na pag dinivide natin yung buong equation by x, so magkakaroon ka lang dito ng dy dx. Diba? So you will form, so y prime, tapos basically ito 0th degree na to. Diba? Okay, so 0th order, saka first order lang yung makikita natin dito na order ng derivatives, di ba? So that's why, so ganito yung pinaka-form, di ba? So ng first order differential equation. So ngayon, nakadepende doon sa value nito kung ano yung magiging solution natin sa problem, di ba? So it will tell us kung siya ba ay variable separable, kung siya ba ay homogeneous, kung siya ba ay linear, kung siya ba ay Bernoulli, kung siya ba ay exact, di ba? So yun kasi yung mga magsasabi sa atin kung ano yung magandang approach, di ba, to solve that differential equation. So yun yung ifo-focus natin sa mga next part ng lecture natin. Diba? So let's try this problem. Okay? So when solving differential equation, meron tayong dalawang solution na sinusolve. No? So the first one is the general solution and the other one is the particular solution. No? Okay? So general solution as the name implies, diba? So from the word general, ang kinukuha natin dito is the form of the equation. Diba? Pag sinabi nating form, so minsan tinatawag natin as the family of curves, no? Okay? So ibig sabihin hindi lang siya isang specific curve, 'di ba? So it can be any curve or it can be any curve. So basta nasa-satisfy niya, 'di ba? So yung form, 'di ba? So nung general solution natin, 'di ba? So for example, halimbawa itong form na 'to, 'di ba? So ano tong family of curve na 'to? Okay? This family of curve is an ellipse, 'di ba? Centered at the origin. Okay? So tapos yun, centered at the origin, diba? So ellipse, so which is centered at the origin. And dito makukuha din natin yung ratio between the major and the semi-major axis, diba? Ito naman, so this is a family of circles centered at the origin. This is a family of a hyperbola centered at the origin. This is also a family of hyperbola centered at the origin, diba? So magkaiba lang dito yung ratio ng transverse sa kanong conjugate axis niya, diba? Okay? So kaya pagdating sa general solution, ang nakukuha natin dyan usually sa family of curves. Diba? So kumbaga, so it is a specific curve, diba? So kumbaga, specific yung shape niya. So pero yung dimensions niya, diba? So can change. No? So yun yung idea natin pag general solution. Pag particular solution naman, so kumbaga, isa lang siyang member ng family of curves natin. Isa siyang specific curve, diba? So particular, diba? From the word particular. So kumbaga, unique, diba? So yung solution natin for the particular solution. So unlike yung general solution natin that can represent a number of curves, diba? Yung particular solution natin isa lang, diba? Okay? So kaya pagdating sa mga differential equation natin, pag particular solution yung sinosolve natin, usually dumadaan tayo sa general solution, then sinosolve lang natin yung unknown constant, diba? Yung arbitrary constant natin. Okay? So yung constant of integration, kumbaga, no? Okay? So let's try answering this problem. So dito ang kailangan natin is a general solution, no? Okay, so now, ang given sa atin dito is y prime, diba? So plus x over y is equal to 0. Okay? So yung y prime is the same as dy dx. So kaya isulat ko na siya as dy dx. Okay? So then this is plus x over y is equal to 0. No. Okay, so now, so itong ganitong uri ng differential equation, so this is what we call variable separable differential equation. Diba? So paano natin malalaman kung siya ay variable separable? So that is pag meron kayo nakitang isang expression, diba? So na pag minultiply natin dun sa differential equation natin, we can separate the variables. Okay, nakuha ba? So nung given sa atin na differential equation, so that's what we call a variable separable differential equation. Okay, nakuha ba? So for example, diba? So let's say we multiply this by, okay, so we have y then multiplied by dx. Okay, nakuha ba? So pag ginawa natin yan, so dito sa first term natin, magka-cancel yung dx. So yung matitira sa atin is y dy. Diba? So then, okay, so dito naman pag multiply natin to magka-cancel yung y. So matitira sa atin ay x dx. So then, okay, so 0, so times y dx is equal to 0. Diba? So again, so then this is what we call a variable separable. So variable separable. Okay? So differential equation. Okay? Nakuha ba? So kasi makikita natin dito, nakaseparate yung mga y, diba? So na variable natin, saka itong mga x na variable natin. Diba? Okay? So any questions, diba? So para dito. So again, so nakaseparate yung y saka yung x. Diba? So again, so that's what we call a variable separable differential equation. Okay? So again, yung tandaan nyo lang dyan is basta bawat term ng variable separable differential equation natin, isang variable lang yung nakikita natin. So even the differentials, dapat kapareho ng variable dun sa nakamultiply sa kanya na function. Diba? So therefore, in general, diba? So note. Okay, so in general, diba? So pag meron kang variable separable differential equation, diba? So tawagin natin to as VSDE. Okay? So for a variable separable differential equation, so ganito yung format niya, diba? So we have a function of x, okay? So multiplied by dx, tapos we have a function of y, no? So again, function ni x multiplied by dx. So let's say this is f1, diba? So then, another function, diba? So function naman ni y, naka-multiply kay dy, diba? So dapat wala kang makikitang ibang variable, diba? So dun sa isang term, isang variable lang dapat. Okay? So pag nabuo natin tong form na to, so then that's what we call a variable separable differential equation. Diba? So usually makikita natin to as para, kasi kung isi-simplify natin yan, parang dy dx, so will be equal to negative, diba? So we have d1, f1 of x divided by f2 of y. Diba? So kaya basta may makita tayo parang fraction, so ng x and y, diba? So like this one. So function lang ni x, function lang ni y, diba? So then, pwede nating gamitan yan na, pwede nating i-simplify yan ito variable separable differential equation. And actually, this is the simplest form so ng differential equation natin. So kasi pag ganito yan, diba? So then if we integrate both sides, so you can imagine this is integral so ng y dy plus x dx, diba? So this is equal to, so integral ni 0, diba? So and by properties of integral, so pwede natin paghiwalayin yung dalawang term na to. So kaya pwede ko itong gawing integral ni y dy, so plus integral ni x dx, diba? So then, integral ng 0 is just any constant. So therefore, this is our constancy. So itong constancy na to yung tinatawag natin constant of integration. Okay. So this is the constant of integration, diba? So or, okay, so yung tinatawag din natin as the arbitrary constant, no? Anong ibig sabihin ng arbitrary constant, diba? Okay? So basically, arbitrary constant is a constant, diba? Iti-treat natin siya as a constant with respect to our variable. So ibig sabihin, even though the variable changes, with respect to that change, hindi nagbabago yung constant natin. Okay, nakuha ba? So that is what we mean by arbitrary constant, diba? It can be any number. So in a way, kasi parang isipin natin, kung pwede magbago-bago yung c natin dyan, di para lang siyang variable, diba? So pero again, so hindi, diba? So constant siyang kino-consider but it can be any value, diba? So yun yung idea natin for a constant. Okay? And again, so for a particular solution, yung arbitrary constant natin is unique. Diba? Okay? So again, so that's the idea. Okay? So yan. So kaya kung kahit anong gawin natin dito sa constant na to, basta yung result natin is still a constant. So ibig sabihin wala tayong minultiply na variable or anything. So then, papalitan lang natin siya ng constancy. No? Kasi for example, yung C na multiply ng 2, so naging siyang 2C. So then this is still a constant. Diba? So kung constant pa rin yan, pwede natin yung palitan ng C ulit. Okay? Okay ba? So again, so that's the idea so for arbitrary constants. No? So again, basta the result is still a constant, so then binabalik lang natin siya sa form na C. Diba? Okay? So any questions dito? Okay, so let's solve this. So by power rule, so this is y squared over 2. Okay, so plus. So power rule, x squared over 2. So this is equal to a constant C. Diba? So note, so kung napansin nyo dito, hindi na tayo nag-add ng C, ng constant dito. Hindi na tayo nag-add ng constant dito. Diba? So kasi bali wala lang yan. Pag pinag-add mo tong dalawa, that will form another constant. Pag sinubtract mo siya dito, that will form another constant. So therefore, ibabalik din natin siya kay C. Diba? So kaya pagdating sa mga solution natin sa variable separable, differential equation, isang beses ka lang mag-a-add ng arbitrary constant. Okay? Naka ba? So mag-a-add ka lang isang beses, diba? So either isa sa kaliwa or isa sa kanan, diba? Kahit hindi na both. So kasi mababaliwala lang yung pag-a-add natin ng arbitrary constant, okay? So ako nung nag-review ako, lagi kong ina-addan ng constancy is yung right hand side. Kasi pag makikita niyo yung mga choices usually pag for a first order differential equation, yung constant natin lagi nasa right hand side, diba? Okay? So again, most of the time lang naman, diba? So not all the time, okay? So pero ganun yung ginagawa ko usually. Diba? So then, para mapalabas natin yung nasa choices, we multiply this by 2. Okay? So then, so pagpapalitin ko tong dalawang to, so you will get x squared plus y squared. So again, this should be equal to 2c. Pero again, so 2c is just another constant. Diba? So kaya, ibig sabihin, gagawin lang natin siyang c. Diba? So this is our equation. Okay? Okay ba? So kaya yung sagot natin dito is letter B. Diba? So this is a family of circles. Okay? Okay ba? So any questions para dito? Okay? So now, so if you want to check your answer, so let's say hindi kayo confident dun sa integration nyo. So karamihan naman kasi ng estudyante ganun. Diba? Okay? So kasi medyo mahirap talaga yung integration. So then, so you can do the opposite. You can check, diba? So by using derivatives. Diba? So ang gagawin nyo lang, kunin nyo yung derivative ng both sides. Diba? So again dito, since yung equation natin is in terms of dy dx, it's better to use the implicit differentiation in this case. No? Okay? So kayo na yung bahala kung gusto nyo gamitin yung partial differentiation. Diba? So pero basically this will be 2x. Diba? So then 2y. So remember, with respect to x to, so y yung variable. So kaya kailangan natin i-multiply ng y prime. So then derivative ng constant ay 0. Diba? So therefore, so we can isolate y prime. So dapat naka-isolate yung y prime dyan. So ibig sabihin, so we need to divide this whole term by 1 over 2y. Diba? So then, so 2 divided by 2 will cancel. 2 divided by 2 will cancel. So we can cancel this. So you will get y prime. Diba? Kasi dito magka-cancel yung y. So kaya y prime plus, diba? So we have x over y. So this is x over y. So this is equal to 0. Okay? So as you can see, pareho lang siya nung given sa problem. So ibig sabihin tama yung nakuha nating sagot. No? So again, so pinakita ko sa inyo itong checking na to. Kasi pag nahihirapan kayo dito sa pag-i-integrate, diba? So pwede nyo gawin is mag-trial and error kayo sa choices. Diba? Kunin nyo yung derivative ng mga nasa choices. Kung alin sa kanila yung magbibigay sa atin ng nasa given na differential equation, yun yung tamang sagot. Diba? So yun yung trial error method na tinatawag. Diba? So or TAE for short. No? Okay? So trial and error. So pero kayo na yung bahala kung gusto nyo gamitin. No? Okay? No ba? So again, so last resort lang to kasi sa board exam, diba? So hindi pwedeng sa board exam tae lang kayo ng tae, no? Okay? So dapat, so nagta-try rin kayo mag-solve. Okay, no ba? So hindi puro tae lang yung ginagawa niyo sa board exam, no? Okay? No ba? So last resort lang 'yan. So minsan kasi time consuming din yung paggamit ng tae, no? Okay? No ba? Especially pag gagamitin natin sa lahat ng choices. And again, so gaya nung sa differential calculus natin last time, diba? So again, so merong chances na magpareho yung nasa choices. So ulitin na naman natin yung tae, diba? So, minsan sayang lang yung oras. Okay? So, I try to solve first. Diba? So, pag hindi nyo talaga kayang isolve, so then, saka lang kayo magtae. No? Okay? So, any questions? Diba? So, para dito. Okay? So, let's try another problem. So, dito naman baliktad. Diba? Okay? So, this time, so we are given the general solution. We are getting the differential equation. Okay? Nakuha ba? And actually, kung makikita natin sa choices, we just need to get the first derivative. Diba? So, ganun lang yung form ng equation natin sa choices. So, kaya dito baliktad. Diba? So, yung ginawa natin sa checking, so yun yung gagawin natin sa problem na yun. So, tapos, hahanapin natin yung differential equation. Okay? So, let's try this. Diba? So, y squared is equal to cx. No? Okay? So, again, so one solution syempre dito is we can directly get the derivative. So, again, since we're solving for y prime, diba? So, then we can do implicit differentiation dito. Diba? So, by getting the derivative of both sides. Diba? So, syempre, pwede rin naman ang gawin natin, diba? So, is yung sa partial derivative. So, pero iwan ko na kayo kung gusto nyo gamitin yung, iwan ko na sa inyo kung gusto nyo gamitin yung partial derivative. Okay? Nakuha ba? So, kasi in this problem, so mas madaling gamitin yung ordinary derivative since maikli lang naman siya. Yung partial derivative kasi maganda siyang gamitin pag medyo complicated yung equation natin. So, mahirap kasing kunan ng ordinary derivative. Diba? So, this is 2y. So, but remember, dx to. So, y yan. So, kaya kailangan natin i-multiply to ng y prime. So, then, so derivative nito is just equal to constant c. Diba? So, therefore, okay, so yung y prime natin is equal to c over 2y. Diba? So, pero, wala naman tayong makikita ganito sa choices kasi wala kang makikita sa choices na merong constant c. Diba? So, basta mga ganitong uri ng problem, so where you are given a general solution, you want to get the differential equation. So, yung tatandaan natin dito, after getting the derivative, ang next yung gagawing goal dyan, diba, is matanggal yung arbitrary constant. So, you need to remove this c here. Diba? But how do we remove the constant c? Diba? So, gagamitin natin yung original equation. Diba? So, from the original equation, constant c is equal to y squared divided by x. Diba? So, therefore, so this will be given by y squared divided by x multiplied by 1 over 2y. Okay? So, then this will cancel. Okay? So, yan yung matitira. Diba? So, you will get that this is equivalent to y divided by 2x. Diba? So, yan yung ating y prime. Okay? Okay ba? So, any questions para dito? Okay? So, another way, diba? So, para i-solve natin yung problem, diba? Eh, since ang goal natin is mawala yung constant, diba? So, what if tanggalin na natin siya sa simula pa lang? Okay? Naka ba? So, paano natin siya matatanggal sa simula pa lang? Diba? So, again, so remember that the derivative of a constant is 0. So, therefore, pag kinuha natin yung derivative, so mas gusto natin pag naka-isolate na yung c. So, one way is by doing this. Diba? But remember, pag ginawa natin to, okay, so itong part na to, gagamit pa tayo ng quotient rule, diba? So it will make it more complicated, diba? And ayaw din natin mangyari yun, diba? So then, so how do we solve this or how do we separate yung constant natin? So mula dun sa x, okay? Nakuha ba? So para pag nag-derivative tayo, mawawala yung constant, okay? Nakuha ba? So ang gagawin natin is gagamitin natin yung concept ng logarithm, diba? Kasi remember sa logarithm, yung multiplication nagiging addition, diba? So yun yung reason kaya sa amplification we use logarithmic scale, diba? So rather than a linear scale, diba? Kasi yung linear scale sa amplification is exponential. So pero pagdating sa logarithmic scale, linear lang yung graph ng amplifier natin, diba? So yung tinatawag natin Bode plot, diba? Isa yun sa mga logarithmic scale natin, diba? Okay? So therefore, diba? So then ang gagawin natin, diba? Since y squared is equal to cx, so again, one property, diba, so of a logarithm, diba, so is, okay? So again, so meron tayong property ng logarithm, diba, so note. So if, okay? So if, diba, so the logarithm, diba, so base b of m is equal to, okay, so is equal to, so we have the logarithm base b of n, diba? So then, okay, so we have m is equal to n, diba? And this is vice versa, diba? So again, so pwedeng baliktaran to. Therefore, if m is equal to n, yung logarithm nila should be equal. So which means we can get the ln of both sides here. So ln ng y squared is equal to ln of cx. Diba? And furthermore, so some properties of logarithm of m to the n base b is simply equal to n times logarithm, diba, so of m base b. Ginamit na natin to in differential calculus, diba? So kaya exponent na to dito, pwede nating ilabas, diba? So we have 2l and y. So then this is equal to, diba? So again, we also have the property logarithm of m times n, so base b is simply the sum of the logarithm of m base b, diba? So and the logarithm of n base b, diba? So which means we can write this as ln c, diba? So we can write this as ln, diba? So c, so plus ln of x. Okay, nakuha ba? So yan yung pwede natin gawin, diba? So now, okay, so ano tong ln c na to, diba? So since c is a constant, so therefore ln of c is just another constant. Okay, nakuha ba? So kaya ang gagawin natin, we can now get the derivative of both sides. Derivative with respect to x, diba? So nang 2 ln y should be equal to the derivative with respect to x, diba? So nang ln of c plus ln of x. Okay, so this will be 2 is constant. We can factor that out. Derivative ng ln is 1 over yung nasa loob. So 1 over y. So by chain rule, so remember that this is dx, this is y. So this should be multiplied by y prime. Diba? So then this will be equal to derivative ng constant ay 0. Derivative ng ln x is 1 over x. So this is 1 over x. Solving for y prime. So then this is equal to y over 2x. So we get the same answer. Okay? Nakuha ba? So pero simula pa lang, diba? So natanggal na natin yung constant c. Na-isolate natin siya kaya nung nag-derivative tayo, nawala siya dun sa equation. Diba? So again, so that's another way. Diba? So again, one way is derivative muna bago natin eliminate, diba? So yung ating constant, diba? So or another way is i-isolate natin yung constant. So then pag kinuha natin yung derivative, mawawala na yung constant doon sa equation natin. Diba? So again, so yun yung mga ways natin to solve these types of problem. Okay? So any questions para dito? Okay. So yan yung solution natin. No? Okay? So actually, pag nagsosolve kayo ng differential equation, so mapapansin nyo rin to. No? So kasi napansin ko rin ito nung nagsosolve ako ng mga differential equation nung nagre-review ako. No? Madalas yung may encounter pag nagsosolve kayo ng differential equation, yung sagot nyo is laging naka-logarithmic form. Okay? Nakaba? So then, sinisimplify lang natin siya para matanggal natin yung logarithm. Kasi karamihan naman ng functions natin, hindi naka-logarithm. Diba? So dun ko na-realize natin na, so pag baliktad, yung kailangan gawin, that is pag general solution, yung given, tapos hinahanap is differential equation, pwede tayong dumaan muna sa logarithm bago tayo gumamit ng derivative. Diba? So then, so pag ginawa natin yun, so yung ibang mga equations natin, mas mapapabilis yung calculation. Diba? So kasi nawawala yung constancy. Diba? Okay? So any questions? Okay. So let's try another. So dito naman, diba? So ang kailangan natin i-solve is the particular solution. Diba? Kasi makikita natin dito yung sa solution natin sa problem, diba? So is meron na tayong kailangan i-solve, diba? So basically after we get the particular solution, meron tayong kailangan i-substitute para ma-solve natin yung isang variable, diba? So determine y when x is equal to 2. So meaning meron tayong particular solution that satisfies this equation here or this given here. No? So yun naman yung dito. So kaya dito naman, ang kailangan nating i-solve is the particular solution. So not the general solution. Okay? Pag nagsosolve kayo ng particular solution, so again, we have two methods na pwedeng gawin. Diba? So the other one is one possible solution is a longer method. So yung longer method natin, ano siya, dadaan ka sa general solution, after nun, so then, saka mo kukunin yung particular solution by evaluating the arbitrary constant. And the second solution is by using definite integral. No? Pero sa definite integral, mag-iingat kayo dyan. Diba? So kasi pag nagkamali kayo sa limits of integration, magkakamali kayo sa sagot. No? Okay? Ang tatandaan nyo lang sa definite integral is dapat meron kayong alam na magka-partner, diba? So dun sa variables natin. Especially pag ang ginagamit natin is variable separable differential equation, diba? So kasi pag variable separable yung differential equation natin, Okay, so then, pag nag-integrate tayo, so lagi siyang with respect to a certain variable. Diba? So kaya dapat yung limits of integration natin, yung lower limit natin, so dapat sila ay related to each other. Tapos yung upper limit natin, sila yung related to each other. Okay, nakuha ba? So yun yung idea. Diba? Okay? So unahin natin yung dadaan tayo sa general solution. So to do that, so let's try to solve this, diba? So by using variable separable differential equation, no? So dito madaling makita na variable separable differential equation kasi kung titingnan natin yung bawat term natin, so bawat factor, so dun sa multiplication natin dito are, 'di ba? So meron silang isang variable lang na involved. So dito x lang, dito y lang, so dito x lang, 'di ba? So dito x lang, tas dito y lang, 'di ba? So therefore, if we divide this by something, dinivide ko to ng x plus 1, madali nating matatanggal to. Okay? Naka ba? So and since hindi natin siya kailangan dito kasi dy to. So ibig sabihin kailangan to dun sa kabilang term, 'di ba? Kasi yung kabilang term natin will be in terms of x, no? So yun yung idea. So basta nakakita kayo ng ganyan, so yung naka-multiply sa dx saka dy are factors, 'di ba? Such that yung bawat factor natin is a single variable only. So again, so malaki yung chance na yan ay variable separable. Okay? So let's try. Okay. Okay? So this is plus x plus 1. So by the way, so yung minomultiply natin sa differential equation para maging solvable siya, 'di ba? So para madali natin makita yung solution is yung tinatawag natin na mga integration factors, 'di ba? So kaya kanina yung mga minomultiply natin. So halimbawa itong y dx na to. So again, this is an integration factor. Okay? So kaya pag nakalagay sa problem, what is the integration factor? Ang hahanapin nyo lang doon is yung i-multiply nyo doon sa buong equation. So para mas ma-solve natin siya. No? So usually ginagamit natin yung concept ng integration factor sa linear differential equation. So first order linear differential equation. No? So anyway, okay, so let's try to solve this. Okay, so doon sa first term natin, ang kailangan nating tanggalin is y minus 1. So, okay. So kaya ibig sabihin para mag-cancel yon, so kailangan natin mag-multiply ng y minus 1 sa denominator. Diba? Okay, so tapos, okay, so dito naman, so ang kailangan natin tanggalin is x plus 1. So therefore, we multiply x plus 1 here. So denominator din, so para mag-cancel. So then, wala naman tayong kailangan i-multiply sa numerator. So therefore, 1 lang. Diba? So then, so again, so looking at the first equation, diba? So first term natin, so again, magka-cancel to. Diba? So kaya matitira sa atin is x over x plus 1. Okay? So kaya this will be x over x plus 1. Okay? So then this quantity dx. Okay? Okay ba? So then plus. Okay? Sa second term naman natin, so magka-cancel naman yung x plus 1. So ang matitira sa atin is 1 over y minus 1. Diba? So we have 1 over y minus 1 dy. Diba? So then dito, so any number multiplied by 0 is 0. So therefore, 0 lang yun. No? Okay? So any questions? So dun sa nakuha natin differential equation. So as you can see, variable separable na to. Diba? So variable separable, so differential equation. Okay? Okay? So variable separable differential equation. So therefore, yung magiging solution lang natin is to integrate so all sides. Diba? Okay? Kagaya ng ginawa natin sa problem number 2. Okay? So any questions dito? Diba? So let's try to solve this individually first, no? So let's try to solve for integral. So ng x over x plus 1. Okay? So then so this is x over x plus 1. Okay, so then this is multiplied by dx. No? Pag nakakita kayo ng ganyang integration, diba? Okay, so yung pinakamadaling way dito so para ma-integrate natin. So since pareho ng form, yung variable natin, tapos constant lang yung nakadagdag sa kanya, diba? So ang gawin nyo lang is, okay, So ang gawin nyo lang dito, dun sa numerator, diba? So mag-a-add tayo ng number na pareho nung nasa denominator, diba? So meaning, diba? So again, this is over x plus 1. So then nag-start to sa x, okay? So then mag-a-add ako dito ng constant na pareho nung sa denominator. So para makuha natin yung form nung nasa denominator, diba? Then since nag-add ako dyan ng 1, kailangan mag-subtract ka rin ng 1, diba? So bakit kailangan pa natin mag-subtract ng 1, diba? So kasi ito yung original na equation natin or expression. So kaya dapat hindi magbago yan, diba? So kaya pag nag-add ka ng 1, kailangan mag-subtract ng 1 para technically nagka-cancel lang sila, no? So ibig sabihin, this is equivalent dun sa original equation natin, no? Okay? So kaya dapat mag-subtract ka rin ng 1, diba? So then by doing so, diba? So makikita natin x plus 1 divided by x plus 1 is 1. So then magkakaroon ka ng minus 1 over x plus 1, diba? So yung idea kasi dito is yung integral ng 1 is easily solvable. Yung integral ng 1 over x plus 1 is just a logarithm, diba? So kaya madali lang siyang isolve. So this will be x minus, so we have ln of x plus 1. Okay, ako ba? So kaya itong una natin dito, so will just be x minus ln, diba? So of x plus 1. Okay, ako ba? So then plus, diba? So again, pag ganitong form, 1 over, so just a first degree polynomial. So logarithm lang yan. So ln of y minus 1. Okay? Ako ba? So yan lang yung magiging equation. So then integral ng 0 is simply a constancy. Okay? So any questions para dito? Okay? So yan. Diba? So yung derivative naman kasi nitong y minus 1 is 1. Diba? Derivative ng y is 1, so derivative ng negative 1 is 0. Okay? So kaya hindi na natin kailangan i-consider yung derivative ng nasa denominator. Okay? Okay, so then, so ibig sabihin so yun yung magiging equation natin. So, kailangan pa ba natin i-solve ito? Sige, wag na lang. Okay? So, okay na siguro to. So, or sige, simplify natin. Diba? Okay? So, makikita natin dito so that this is subtraction. Diba? So, kasi minus to, plus plus to. So, remember sa logarithm, pag nag-subtract tayo, pwede nating i-divide yung nasa loob. Diba? So, therefore, magigitong ln. Diba? So, of. Since ito yung positive, ito yung nasa numerator. So, then ito yung negative. So, ito yung nasa denominator. So, this will be x plus 1. So, then this will be equal to c minus x. So, nilipat ko yung x dito sa kabila. Okay? So, this is c minus x. Okay? So, then, so para matanggal natin yung ln, so we just raise this from e. Okay? So, then this will cancel. So, then solving for y. So, therefore, so you will get y. So, will be given by, okay? So, this is x plus 1 multiplied by, okay? So, dito, so pwede natin gamitan ng property of exponential, diba? So, yung loss of exponents na tinatawag natin. Okay? So, then, so by loss of exponent, okay, so pwede natin itong gawing e to the c multiplied by e to the negative x. Diba? But remember that e to the c is just a constant. So, therefore, we can replace this by c. Diba? So, pwedeng isipin natin dyan as just another constant c. Diba? So, then meron pa tayo ditong plus 1. Diba? So, which means, okay, so ito yung magiging equation natin. So, y is equal to constant c. So, times x plus 1. So, times e to the negative x. So, then plus 1. Okay? So, again, so this is our general solution. Okay? So, for the particular solution, kailangan lang nating evaluate yung c. And alam natin, so that if y is equal to 2, x is equal to 1, so yun yung tinatawag natin as the initial condition. Diba? Kaya yung mga gantong uri ng problem, so ito yung tinatawag natin ng mga initial value problem. Diba? So yun yung mga problem na nag-i-involve ng initial value. So kasi usually ang hinahanap dyan is the particular solution. Okay? So again, as a given, so if y is equal to 2, x is equal to 1. So we substitute that. Y is 2, x is 1. So this is e raised to negative 1. So again, so this is plus 1. So then we can solve for c here. Okay? So again, so rearrange nyo na lang yung equation or pwede kayo mag-shift solve kung gusto nyo. No? So 2 minus 1 divided by 2. Okay? times E. Okay, so you will get that this is just equal to E over 2. Okay, so yun yung constant C natin. Diba? So now that we have constant C, okay, so ano na yung next step natin dyan? So we will solve yung pinapasolve sa problem. Diba? So then, okay, so at x is equal to 2, so kailangan natin isolve si y. So using this equation, so then you will get y is equal to, so again, yung constant C natin is E over 2. So this is E over 2. No? So then, multiplied by x plus 1. So again, x plus 1. So yung x ay 2. Pinalitan ko na kagad. So then e raised to negative 2. So then this will be plus 1. Okay? So therefore, solving for y. So we have e divided by 2 multiplied by 3 multiplied by e raised to negative 2 plus 1. So you will get that this is equal to 1.55. Okay? So therefore, the answer is letter C. Okay? So any questions para dito? Okay. Okay. So again, another solution is by using definite integrals. No? Okay. So ang gagawin natin dito, diba? So mas convenient sa atin. Okay. So isulat ko ulit yung differential equation natin kanina. So we have x over x plus 1 dx. No? Okay. So then plus. Okay. So 1 over y minus 1 dy. Okay. So this is equal to 0. So yung gagawin ko dito yung x na to, sililipat ko dun sa kabila, diba? So you will form 1 over, so y minus 1 dy. Okay, so this is equal to, so we have negative, so x over, so x plus 1. Okay, so again, mas convenient sa atin yung ganitong form. Okay, so x over x plus 1. Okay, so para, kumbaga naka-isolate na yung x and y natin. So as a right-hand side and the left-hand side of that equation. So kaya pagdating sa simplifying natin mamaya, diba? So then mas madali na siyang masosolve, diba? So let's try to integrate both sides, diba? So labas ko na yung negative dito. Okay? Since negative is a constant. Okay? So then again, sa paglalagay ng limits of integration, dapat consistent kayo, diba? For example dito, y is equal to 2 when x is equal to 1. So kaya pag 1 yung nilagay ko dito, ito yung ilalagay ko dito. Pwede nyo rin ilagay sa upper limit kung gusto nyo, diba? So pareho lang naman yung kalalabasan. Diba? So pangalawa, hinahanap natin yung y when x is equal to 2. So we can let this 2. So then dito, hindi pa natin to alam. So kaya gawin muna natin y. Diba? So we can do that. Diba? So therefore, okay, so we can solve this. Again, this is simply ln of y minus 1. So as we solved earlier, so then this is from 2 to y. Tapos ito, solve na natin sa calculator. So para hindi na natin kailangang i-integrate. Diba? Okay? So pag sinolve natin yan, so you will get, okay? So this is negative 0.595. Okay? So then solving this, so at y is equal to y, so that is simply ln of y minus 1 plus, so at y is equal to 2, that's ln of 2 minus 1. So this is equal to negative 0.595. Diba? So ln of 1 is 0, so therefore this is 0. So para matanggal tong ln ito, so we raise this from e, raise din natin to from e. So then this will cancel. So then solving for y, so this is equal to 1 plus e raised to negative 0.595. Okay? So solving for y, diba? So you will get 1.55 as well. So pareho lang yung kalalabasan, diba? So although parang medyo maikli yung solution natin, diba? So so dumiretso tayo sa particular solution, diba? So pag nakuha nyo na to, so pag nakarating na kayo sa part na to, pwede na kayo dito mag-shift solve, no? Makukuha nyo na rin dyan yung 1.55 natin. Okay, so any questions para sa problem na to? Okay. So sa inyo yung difference ng particular sa general solution. Sa particular solution, wala na tayong arbitrary constant, diba? Sinosolve natin yung arbitrary constant using the initial values, no? Pero pag general solution, meron pa tayong arbitrary constant. Okay? So any questions so far? Okay. Next, number 5. Diba? So itong number 5 naman is an example of differential equation na hindi variable separable. Diba? So paano natin nasabi na hindi siya variable separable? Kasi yung isang factor, diba? So nung isang term natin, so contains two variables. No? And hindi na natin yan ma-factor out. Diba? Kung ma-factor out man natin yan, so even though we include complex number, so again, it will also contain x and y. No? So kahit anong gawin natin dyan, diba? So it will always contain two variables. So kaya hindi natin masaseparate yung x squared sa yung y squared na yan. So itong 2xy sana, diba? So pwede natin siyang gawing variable separable. So pero, so again, so in this case, so hindi natin siya magagawang ganun. No? Okay? So let's try to solve, diba? So this type of problem. Okay? Okay, diba? So yung una natin gagamitin dito na solution, diba, is yung solution natin for a homogeneous differential equation. Okay? Nakuha ba? So paano ba natin malalaman kung ang isang solution, diba, yung isang problem natin is a homogeneous differential equation, diba? So dapat so para maging homogeneous differential equation, diba? So dapat ito naka-multiply sa dx, saka yung naka-multiply sa dy natin are homogeneous function of the same order. Okay, nakuha ba? So na homogeneous function. Okay? So paano natin malalaman kung homogeneous function siya? So test muna, 'di ba? So so this is the test of homogeneity, 'di ba? So para malaman natin kung siya ay homogeneous, first order differential equation, 'di ba? So note, iba yung definition ng first order homogeneous differential equation, 'di ba? So sa higher order homogeneous differential equation, 'di ba? So again, so yung test natin, diba, is mag-let muna tayo. So let, diba? So let's say we have f1 so of xy, diba? So be given by, so yung naka-multiply sa dx, that is x squared by plus y squared. Okay? So ang gagawin lang natin dito is papalitan natin yung x ng zx, papalitan natin yung y ng zy, diba? So then pag na-factor out natin yung z, diba? So that is a homogeneous function. Diba? So makikita natin dito, this will be zx squared plus this will be zy squared. Okay? So then we can factor out z squared. Tapos makikita natin, so na mapapalabas uli natin yung original function natin. Okay? So again, so we can factor out z squared here. So then this will become x squared plus y squared. No? So again, which is the original function. So ibig sabihin, this is equivalent sa z squared. So then this is f1, diba? So of xy. Okay? Nakaba? So then we can see, diba? So that this is a homogeneous function, diba? Of the second order. Kasi naging squared yung z. Diba? So kaya kung titignan natin dito, so sa zx, zy natin, parang finactor out natin tong z. So tapos nagkaroon siya ng square. Diba? So this is a homogeneous function, diba? So of degree 2. Okay, or a second order homogeneous function. Okay, so then, so let f2 of xy naman, so let's use naman yung isa pang function natin, yung naka-multiply naman kay dy. So that's 2xy. So ganun din yung gagawin natin dito, diba? So we will replace x by zx, we will replace y by zy. So then this will be 2, so times zx multiplied by zy. Okay? So then this will be equal to, so we have 2 z squared. So we can factor out yung z squared natin. So tapos makikita natin na bumalik din siya sa 2xy. Diba? So therefore, so we can say, so that f2, diba? So of zx, zy, so is just equal to z squared, diba? Ng f2 of xy. Diba? Okay? So ibig sabihin, this is also a homogeneous function, diba? So of degree 2. Okay? Since pareho sila ng degree and pareho silang homogeneous function, ibig sabihin, so this is a homogeneous differential equation. Okay, so differential equation. So again, so this is first order, no? Sa higher order differential equation kasi natin, iba na ang definition ng homogeneous, no? Okay? So any questions dito? Okay? So then, So let's try to solve this, di ba? So pag nakita nyo ng homogeneous differential equation, so then ganito yung paraan ng pagsosolve natin, di ba? So magle-let tayo, di ba? So ng isang variable, di ba? So let's say, so we have y is equal to vx. Okay? So again, so or, pwede nyo rin gawin na x is equal to vy. No, so pero isa lang dito yung gagana sa problem kasi pag nagkamali kayo ng gamit dito, so mas magiging komplikado yung equation natin. Ang goal kasi natin dito is maging variable separable yung differential equation natin. So in this problem, so ito yung gagana diyan, no? Pag ang ginawa niyo is x is equal to vy, so the problem will become more complicated, no? Kaya pag nakita niyo pag nakita niyo na yung patutunguhan ng solution niyo is magiging mas komplikado yung formula, so then baliktarin niyo lang yung equation. Diba? So if we do this, diba? So then we can say that dy is simply equal to v dx plus x dv. So remember, this is by product rule. So then ipapasok natin tong dalawang equation na to dun sa original na differential equation natin. So again, so from our differential equation, x squared plus y squared dx, no? So plus 2xy dy. So this is equal to 0. Okay? So then, so palitan natin yung y ng vx. So this will be x squared plus, so this will be vx. So this quantity squared. So then dx, diba? So then this is plus, okay? So again yung y, papalitan natin ng vx, no? Tapos yung dy naman, papalitan natin ng v dx plus x dv. No? Okay? So then, so this is equal to 0. So then we simplify. So x squared, we can factor out x squared here, diba? So this is x squared multiplied by, okay, so dito ang matitira ay 1, tapos dito naman ang matitira ay v squared. So then this is dx, diba? Plus, so dito pwede rin natin i-factor out yung x squared kasi meron ka ditong x, diba? So may x ka dito, tapos may x ka rin dito. So we can factor out yung x squared dito, diba? So we have x squared, okay? So multiplied by, okay? So ang matitira sa atin dito ay 2v, diba? So multiplied by v here, so we have 2v squared dx, diba? So then, so we also have 2v multiplied by x dito. So kaya plus 2xv dv. Okay, so this is equal to 0. Diba? So then, so we can cancel yung x squared. So kasi pareho may x squared yung term natin. So kumbaga pag dinivide natin yung x squared sa buong equation, magka-cancel lang yung x squared. Diba? So then we simplify, diba? So yung may mga dx, so itong dalawang to, so pagsamahin na natin to. So 1 plus v squared plus 2v squared, that's 1 plus 3v squared. Okay? So again, so this quantity dx. Okay? So then plus, diba? So we have, so yung 2xv dv, diba? So ngayon, ano napansin natin dun sa equation? So this changed to a variable separable differential equation. So kasi makikita natin yung mga naka-multiply, so we only have single variable, so for each one. Diba? Okay? So again, so meron silang kanya-kanyang sariling variable. Diba? So tas isang variable lang. Diba? So again, so unlike dito na meron kang dalawang variable dun sa isang factor. So kaya alam natin that this is a variable separable differential equation. Diba? So then, okay? So ano yung kailangan natin i-multiply dito? So para ma-separate natin yung variables. So dun sa unang term, so kailangan natin tanggalin yung 1 plus 3v squared. So kaya i-multiply natin ito ng, okay, so 1 over. Okay, so we have 1 plus 3v squared. So second term naman natin na kailangan natin tanggalin dito is yung x. So we have x. So yun yung kailangan natin i-multiply dun sa equation. Diba? So dun sa first term natin, so magka-cancel lang to. Diba? Okay? So kaya matitira lang sa atin dyan is yung dx divided by x. Diba? So we have dx over x. Okay? So tapos dito naman sa second term natin, so ang magka-cancel naman dyan is yung x. Diba? So ito naman yung magka-cancel dyan. So yung x. Okay? So therefore, so yung matitira naman sa atin dyan ay 2v divided by, so we have 1 plus 3v squared. So this will be dv. Okay? So then this is equal to 0. So as you can see, nakaseparate na yung variables natin. So this is now a variable separable differential equation. Diba? So all we have to do is to get the integral, diba? So of all these terms. Okay? Okay ba? So yun yung gagawin natin. Okay? So integral ng dx over x is just a simple ln x. No? Okay? So then, try natin i-solve ngayon yung integral ng 2v over 1 plus 3v squared. So gagamit lang tayo dyan ng substitution. Diba? So substitution method. Okay? So let's try to solve that. No? So again, integral ng 2v over 1 plus 3v squared. So then dv. Diba? So ilalet lang natin yung nasa denominator. So 1 plus 3v squared. So tawagin natin to as u. So then you will get du is equal to 6v. Diba? So para maging 6v, yung nasa numerator natin, so again that should be 6v. So then dv. Diba? So para mapalabas natin yan, kailangan natin mag-divide ng 3. Diba? 6 divided by 3 is 2. Diba? So kaya ganyan yung mangyayari. So then this will be 1 plus 3v squared. So then, okay, so pag sinubstitute natin, we can factor out 1/3. So then this will be integral. Diba? So ng 6v dv is now our du. So then yung 1 plus 3v squared is u. Diba? Okay? Okay? So kaya lalabas dito is 1/3, diba? So of ln u. Diba? So ngayon, yung u natin so is 1 plus 3v squared. So therefore, this will be 1/3, diba? So of ln. So ng 1 plus 3v squared. Okay? So again, so yan yung solution natin. Diba? Okay? So therefore, okay, so this will be 1/3. So ln, diba? So of 1 plus 3v squared. Okay, so then this is equal to, so we have a constancy. No? Okay? So then we can multiply this whole equation by 3. No? So para mag-cancel yung 1/3, so you will get 3 ln x. Okay? So then plus. Okay, so this will be ln, diba? So of 1 plus 3v squared. Okay? So then this is equal to, so again, 3 times a constancy is just another constant. So kaya babalik lang siya sa constancy. Diba? And by properties of logarithm, yung 3 na to pwede nating ilagay as an exponent nung nasa loob ng logarithm natin. So therefore, we can write this as ln of x cubed. Okay? Ako ba? And by properties of logarithm, pag addition, pwede nating i-multiply yung nasa loob. Diba? So therefore, you will form ln. Okay? So this is multiplied by, okay? So we have x cubed. No? So this is x cubed multiplied by, so we have 1 plus 3v squared. Okay? So then this is equal to constancy. Diba? So and lastly, diba? So yung kailangan natin gawin dito, so is, okay, so we need to replace v, diba? So or we need to change back, diba? So yung v natin papunta sa in terms of x and y. So kaya mula dito, so solve natin yung v. So v is equal to y over x. Kailangan natin tong ipasok dun sa equation natin. Okay? But before that, let's remove the ln. So again, so this can cancel and e to a constant is just another constant. So we can just replace this by c. Diba? So therefore, diba? So ito na yung magiging equation natin. So you will get x cubed. Okay? So this will be x cubed. So x cubed times 1, that's x cubed. Diba? So then plus. So x cubed times 3v squared. So that's 3x cubed v squared. So then this is equal to a constancy. Diba? So then this will be x cubed. Diba? So plus 3x cubed multiplied by, so this is y over x. This quantity squared. So this is equal to constancy. Diba? So x cubed divided by x squared, magka-cancel yung x squared. So kaya may matitira ka pang isang x dito. Diba? So therefore, so lalabas na x cubed plus 3. Okay, so this will be xy squared. So it's equal to a constancy. So therefore, so yan yung sagot natin. No? So this is letter A. Okay? So any questions? So para dito? Okay, so again, so yan yung solution natin. So for a homogeneous differential, homogeneous first order differential equation. No? So medyo mahaba nga lang siya. No? So kasi mahaba yung pagsisimplify, diba? So using algebraic manipulation. No? So any questions para dito? Okay. So again, that's one solution. Diba? Yung isang solution na pwede pa natin gawin dito sa problem number 5, diba, is by using the concept naman ng exact differential equation. No? Okay? So yung tatandaan naman natin sa exact differential equation, diba? So is, okay? So basically, if we consider, so let u, no? So be equal to f of xy, a function of xy, which is equal to a constant c. Na-discuss na natin to back in differential calculus. Then by definition, if I solve for du, this is equal to partial of u with respect to x dx. So plus partial of u with respect to y dy. So then this is equal to, so again, derivative ng constant ay 0. So therefore, we can form this differential equation. So ibig sabihin, if we can find a function u, if u exists, diba, such that yung partial niya with respect to x, siya yung nakamultiply kay dx. Tapos yung partial niya with respect to y, siya yung nakamultiply kay dy. Yan yung tinatawag natin na exact differential equation. Okay? Tama ba? So kaya para matest natin kung siya ba ay isang exact differential equation, so itong nakamultiply sa dx, kukunin natin yung partial niya with respect to y. Tapos itong nakamultiply kay dy, kukunin natin yung partial niya with respect to x. Diba? Kasi meron tayong property sa differential equation, so na pag kinuha mo yung partial with respect to x, diba? So then, kinuha mo yung partial with respect to y, so of a two-variable function, dapat pareho lang siya. So pag inuna natin yung pagkuha ng partial with respect to y, bago yung partial with respect to x. Diba? So that's the partial, so with respect to x, diba? So ng partial with respect to y. Okay? Okay ba? So should be equivalent sa partial with respect to y. So then partial with respect to x. Okay? So again, so yun yung reason. So pag kinuha natin yung partial with respect to y, nung nakamultiply sa dx, dapat pareho lang siya sa partial with respect to x nung nasa dy. Diba? So therefore, so ito yung test of exactness naman, yung tawag dito. So for the test of exactness, diba? Okay, so tawagin natin to as m saka n. Diba? So then we get the partial of m with respect to y. So kasi dx to. So then this will just be equivalent to, so again, since dito, tinitreat natin yung x as constant, derivative ng x squared is 0. Diba? Then derivative ng y squared is 2y. Okay? Okay ba? So that's 1. So para naman kay n, since nakamultiply siya kay dy, we need to get the partial with respect to x. Diba? In this case, 2x is constant, so we can factor that out. 2y is constant. Okay? So we can factor that out kasi nga with respect to x to. So y is constant. So then derivative ng x ay 1. So kaya ito lang yung matitira. So as you can see, these two are equal. So ibig sabihin, so this is exact differential equation. Okay? Nakuha ba? So again, so yun yung tinatawag naman natin na test of exactness. Diba? We get the partial derivatives, diba? So nung dalawang term natin. Okay? So any questions? Diba? So para dito. Okay, so then, so paano natin solve ngayon yung u? Diba? So again, so ang ibig sabihin kasi nito nakuha natin is itong nakamultiply sa dx is partial ng isang function with respect to x. Ibig sabihin, nakuha natin to, diba? So by treating y as constant, so then getting the derivative with respect to x. Okay? Nakuha ba? So kumbaga, so we can say that partial of u with respect to x, diba? So it's just equal to, so we have yung nakamultiply ngayon kay dx. So x squared plus y squared. So kaya para ma-solve natin yung u, or at least yung parang draft, diba? So nung u natin, okay? So then, so we just integrate. So yung x squared plus y squared natin, dx, diba? So treating, okay? So yung y natin as constant. Okay? Okay ba? So by doing so, so then this will be, okay? So yung x squared natin, so pag kinuha mo yung integral niya with respect to dx, so this is simply power rule. So this is x cubed over 3 or 1/3 of x cubed, diba? And since we are treating y squared as constant, pwede mo siyang ilabas ng integral. So then y squared. So then we have integral ng dx that is simply x. Diba? So kaya magiging siyang y squared x. Okay? So then, diba, so remember, so pagdating sa integration, meron tayong dinadagdag dito na constant of integration. But remember that dito, tinitreat natin yung y as constant. So therefore, any function na ang laman lang is y, so can be treated as constant. Diba? So hence, pag kinuha mo yung partial derivative with respect to x, that will be 0. So therefore, so there should be something here na function ni y. Diba? Pag kinuha mo yung partial derivative nito with respect to x, 0 lang yung lalabas kasi tinitreat natin yung y as constant. Diba? So therefore, this is one form, diba? So nung ating function u na hinahanap. Diba? Pangalawa, diba? So alam natin na yung partial naman ni u with respect to y, so should be, so yun naka-multiply kay dy. So therefore, this is 2xy. Diba? So ibig sabihin, to find the form of u, so again, another ways we get the integral of 2xy. So this time, so with respect to y, pero ititreat naman natin this time yung x as constant. Diba? So again, so another form ng u natin, diba? So will be given by, so since 2x is constant, we can factor that out. So then, diba? So we get yung y squared over 2, diba? So this is by power rule. Okay? So again, so this will be y squared over 2, diba? So again, this is by power rule, diba? So then, okay, so magka-cancel to. So this time, x naman yung constant, kaya meron tayong naka-add dito na something na function lang ni x, diba? So then, so yung u natin, so will be of the form. So again, this is xy squared. So then this will be plus g of x, diba? So remember kanina, okay, so nung ito yung kinonsider natin, yung nakuha natin na form is 1/3 x cubed. So plus xy squared. So then this is plus f of y. Okay? Nakuha ba? So kaya makikita natin, so na pag pinag-compare natin tong dalawang to, so definitely, diba? So meron tayong xy squared term. Diba? So and by comparison, so yung g of x dito is simply yung 1/3 x cubed natin. Okay? Nakuha ba? And itong f of y naman na to, diba? So since wala siya ditong f of y, so ibig sabihin, so this is either constant or 0. Okay, nakuha ba? So we can say that this is just a constant c. Okay? So kaya i-combine natin yung mga nakuha natin dyan. So therefore, yung hinahanap natin na u dito, diba? So which is a function of x and y, diba? So will be composed of, so yung 1/3 x cubed. Okay? So yun yung g of x natin, diba? So then, plus xy squared. Okay? So then plus constant c. Okay? Nakuha ba? So again, so yun yung function u natin, diba? So and again, ganito yung format ng equation natin. So we have u is equal to f of xy is equal to a constant c. Diba? So therefore, we can say that this is just equal to another constant. So let's say c1. Diba? So kaya pag pinag-subtract natin tong dalawang to, so magiging isang constant lang yan. Diba? So therefore, so we can assume, diba? So na parang we only have this one is equal to a constant c. Diba? Kaya sabi ko kanina, pwede rin natin tong gawing 0. Diba? Kasi may constancy na tayo dito. Okay? So isa lang kasi yung arbitrary constant natin, diba? So then by multiplying this whole equation by 3, diba? So para mawala yung 1/3, so you will get x cubed plus 3xy squared. So then 3 times a constant is just another constant. So therefore, we can just write that as constancy. No? So makita natin parang medyo mas maikli yung solution nito compared sa homogeneous differential equation. Okay? Kaya dati nung nagre-review ako, inuuna ko is yung test of exactness. No? Kasi mas madali siyang gamitin compared dun sa homogeneous differential equation. Okay? Pag hindi gumana yung test of exactness, saka ko gagamitin yung test of homogeneity. So remember, dito sa problem na to, nagkataon lang na homogeneous differential equation siya and at the same time, exact differential equation siya. Diba? So syempre, may possibility na hindi siya exact pero homogeneous siya, or exact siya pero hindi siya homogeneous. So pwede rin hindi siya exact and hindi rin siya homogeneous, diba? So again, so gamitin niyo lang kung ano yung mga applicable, diba? So na pwede natin gamitin, okay? So ang ginagawa ko dati, so ang una kong i-check is kung variable separable ba siya, diba? Kung hindi siya variable separable, so then titingnan po kung siya ay exact differential equation, diba? So kung hindi siya exact differential equation, so then kung siya ba ay homogeneous differential equation, diba? So yung linear kasi, so yung linear differential equation sa Bernoulli differential equation, madali siyang makita, diba? So kaya parang ka-level siya nung sa exact, no? So ang gagawin ko lang doon is tignan natin kung variable separable siya. So tapos by visual, diba? By observation, so check niyo lang, tignan niyo lang kung possible ba na siya ay linear, diba? Or possible ba siya na siya ay Bernoulli, diba? So then pag hindi gumana 'yon, so then saka ko i-check yung exactness or yung homogeneity. No? Okay? So, ganun lang yung ginagawa ko dati pag nasusolve ako ng differential equation. Okay? So, pero depende sa inyo kung mas preferred nyo is yung sa homogeneous differential equation, so then, so gamitin nyo. Diba? Okay? So, kung yan yung mas preferred nyo compared dun sa exact. No? So, any questions? Diba? So, actually, pwede rin kayo ditong mag-substitution. Okay? Okay, so pwede rin kayo dyan mag-substitution, 'di ba? So pero kung substitution yung gagawin yung solution sa problem na to, dapat alam niyo yung exact form ng function natin so before the substitution. Okay, nako ba? So ayan. Okay, so kasi kung napansin niyo dito sa problem na to, okay? So for this problem, okay? Pag sinimplify natin to, so this will be x squared dx, 'di ba? So plus y squared dx, 'di ba? So then, okay? So we have yung 2xy dy. Okay? So we have x squared dx plus y squared dx plus 2xy dy. Diba? So yun yung buong expression natin. So kung napansin nyo to, itong x squared dx, dito siya nanggaling sa x cube. Okay na ko ba? Kasi yung derivative ng x cube is 3x squared. Diba? So kumbaga nawala lang yung 3. Diba? So dito. So pero dito nanggaling yan sa x cube. So therefore, saan nanggaling to? Part na to. Diba? So dito siya nanggaling sa xy squared. Okay? Tama ba? So kung na-realize niyo yun, diba? So yung part na yun. So dito sa xy squared. Okay? So kung na-realize niyo yung part na yun, diba? So nanggaling lang siya dun sa format na xy squared. So then, so try nyo na lang hanapin yung, magbibigay sa inyo ng ganitong format. Diba? So ng equation pag kinuha nyo yung derivative. Ano ba yung derivative ng xy squared? So xy squared, pag kinuha ko yung derivative nito, so by product rule, so this is simply, so x times 2y dy plus y squared, so times dx. Diba? So, or we can rearrange this as y squared dx plus 2xy dy. Okay? So, kung napansin nyo yan, so yan yung given sa atin. Diba? Okay? So, y squared dx plus 2xy dy. Okay? So, kaya kung na-realize nyo yan, so pwede kayong gumamit ng substitution dito. So, we have x squared dx, so plus, okay, so ano nga to? So y squared dx, no? Plus 2xy dy. Okay? So gamit lang kayo ng substitution. So let u be equal to, so xy squared. So then du, so will be given by y squared dx plus, okay, so plus 2xy dy. Diba? So okay, basically yung equation natin will just become x squared dx, no? Plus du is equal to 0. So then by integrating, so you will get 1/3 x cubed, diba? Plus u is equal to constant c. So balik lang natin si u. So si u is xy squared is equal to constant c. Multiply this by 3. So we have x cubed plus 3xy squared is equal to constant c. Diba? So maikli lang din yung solution. Okay? So pero kung na-realize nyo lang yung part na yan. Diba? So kaya isa rin sa magiging skill, diba? So na kailangan nyo pagdating sa board examination is observation. Okay? Okay ba? So, yan. So, kasi kung napansin nyo talaga itong yung part na to. So, if you expand, diba? Tapos, pag i-compare mo sa choices, lahat ng choices may x cube. Diba? And makikita natin, again, derivative ng x cube, x squared. Diba? 3x squared. So, ibig sabihin, itong form na to, nanggaling yan dun sa x cube. Okay? Okay ba? So, kung nanggaling sa x cube yung x squared natin, ibig sabihin, itong part na to, nanggaling dun sa isang term. So, kaya dalawa lang yung pamimilian nyo dyan. Xy squared or x squared y squared. Diba? Okay? Okay ba? So, kaya tignan nyo lang kung alin dyan yung kailangan nyo dun sa problem. Okay? So, again, so that's another way. Diba? So, yun yung swerte natin sa board exam kasi multiple choice. Diba? Pag na-stuck tayo sa problem, so we can just look at the choices para magkaroon tayo ng clue ano dapat yung patutunguhan ng equation natin. No? Okay? Okay ba? So kaya isa rin yan sa mga skill na magigain niya, diba? So pag nagre-review kayo sa board examination, diba? So yung back solving. Okay? So any questions? So para dito? Okay. So again, so yan yung homogeneous saka yung exact na differential equation. So I think abot pa naman tayo sa isang topic, no? So let's discuss this one. So ito naman ay linear differential equation, no? Okay, so itatandaan nyo lang sa linear differential equation, diba? So we have linear DE, okay? So is that yung format natin for a linear differential equation, diba? So is y prime. Okay, so this is plus. So we have a function of x or the function of the independent variable times y. So then this is equal to so a function of x, another function of x. So this is a linear differential equation. So by definition kasi pag sinabi natin linear differential equation, so meron tayong I think tatlong rules na kailangan tandaan dito. So yung una, diba, is yung mga dependent variable natin saka yung mga derivative natin dapat is power of 1 lang. So ibig sabihin hindi siya dapat naka-square, hindi dapat siya naka-cube, diba? So kaya dito yung y prime natin saka yung y, so again hindi siya pwede magkaroon ng exponent. Diba? So other than 1. Okay, naka ba? Pangalawang rule natin, diba, is hindi tayo pwede mag-multiply ng dependent variable sa derivative niya or sa sarili niya, diba? So ibig sabihin, so hindi rin tayo pwede makakita for example ng y prime, diba? So para do sa first order. Okay, so kaya dito yung y saka yung y prime magkahiwalay. Diba? Okay? And pangatlo, na rule natin is dapat, okay, so yung ano pa ba? Dapat yung derivative natin is wala sa loob ng another function. Ay nakaba? So or yung dependent variable natin. Kaya hindi tayo pwede makakita for example ng sin y or ln y prime. So these are not linear. Diba? So yun yung tatlong rules na kailangan yung sundin para masabi natin na siya ay linear differential equation. Kung meron mang naka-multiply dun sa mga derivative natin saka sa function, dapat function lang siya ng independent variable. Diba? So kaya this is what we call a linear differential equation. Pag first order, so ganito yung itsura niya. Diba? Okay? So then, so pag ganito yung itsura ng linear differential equation, so ito lang yung mga tatandaan nyo. Diba? So una, diba? So pag na-identify nyo na itong P of X saka Q of X, is isosolve natin yung tinatawag natin na integrating factor. So phi of x, diba? So which is just given by e raised to integral so ng P of x dx. Okay? So again, so this is what we call the integrating factor. Diba? Pangalawa, pag na-solve yun na yung integrating factor, so then pwede na nating ma-solve yung linear differential equation. So ang general solution natin, diba? So pag nakuha na natin yung integrating factor natin is y multiplied by phi. Okay, so this is equal to, so integral, so ng q of x, phi of x, dx. So this is plus constants. Okay, nakuha ba? So actually, pwede nyo itong ma-derive kung gusto nyo siyang i-derive, diba? So again, so ang idea lang dito is product rule. Okay, nakuha ba? So yung product rule. So kumbaga magsa-substitution lang tayo, magle-let lang kayo ng, let's say u is equal to y times phi, diba? So then you will get that du dx, diba? So will just be given by, so this is y prime, so times phi, diba? So then plus, so phi times y prime, diba? So kaya basically pag minultiply natin yung buong expression natin by phi, okay? So makikita natin ay nandiyan yung y prime times phi, diba? So y prime times phi. So tapos itong phi times, baliktad pala ito, sorry. So y times p prime, y times phi prime. So therefore, so dito meron kang y. So ibig sabihin pag nakahanap ka ng integrating factor, kung saan yung derivative niya is equivalent dun sa sarili niya, multiplied by another function of x, diba? So then, okay, so you can just replace itong buong left-hand side natin by u prime, diba? Okay, nakuha ba? So kaya pag in-integrate natin, lalabas yung u or yung y phi. Okay? So again, so if gusto niyo siyang i-derive, no? Okay? So pero again, so dito enough na memoryahin niyo yung format, diba? So ng pagsosolve natin ng linear differential equation. Okay? So kasi ganyan lang kadali yung linear, yung pagsosolve ng linear differential equation. So actually mas madali siya dun sa homogeneous saka dun sa exact, diba? Okay? So let's try, diba? So for this problem, so again dy dx is y prime. So kaya isulat ko na lang siya as y prime, diba? So then minus, so then so we can or gawin kong plus. So I will factor here, so negative 3y over, or 3 over x. So we have negative 3 over x, diba? So multiplied by y. Okay, so ito yan. So yung negative 3y over x. So this is equal to x cubed. Diba? Kung i-compare natin siya dun sa form ng ating linear differential equation, ito yung lalabas na p of x natin. Tapos ito yung lalabas na q of x natin. Diba? So therefore, first step natin is to solve for that integrating factor. So again, this is given by e raised to integral, so ng p of x dx. Diba? So this is equal to e, so raised to integral, so ng negative 3 over x dx. So then, so negative 3 is constant, so we can factor that out. So then, ang integral ng dx over x ay ln of x. So note, hindi na natin kailangan lagyan dito ng plus constancy. Kasi magka-cancel lang siya dun sa buong equation natin later on pag nilagyan natin siya ng plus constancy. So therefore, so ito na lang yung gawin natin. Diba? So pag ginawa natin yan, so then by property of logarithm, so pwede natin ipasok yung negative 3 as an exponent. So then this will cancel. So then this is x raised to negative 3 or 1 over x cubed. Diba? So this is our phi of x. Diba? So then following this equation, so for the general solution, diba? So therefore, so ito yung general solution natin. So we have y multiplied by 1 over x cubed. Okay? So then this will be equal to, so we have integral, so ng q of x, x cubed. Diba? So then we have phi of x, 1 over x cubed. So then dx, diba? So then we have plus constancy, diba? Where this will just cancel, diba? So you will get y over x cubed is equal to, so we have integral ng dx is x plus constancy. So then multiplying this whole term by x cubed, diba? So you will get y is equal to x to the fourth, diba? Plus cx cubed, no? Okay? So then, so meron na tayong general solution, diba? So pero yung kailangan natin dito, as you can see, is the particular solution. So kaya kailangan nating isolve yung constancy. Diba? So from the given, so y of 1 is equal to 4. Ibig sabihin, pag yung x natin ay 1, yung y natin ay 4. Diba? So at x is equal to 1, y is equal to 4. So by substitution, 4 is equal to 1 to the 4th power plus c, so times 1 to the 3rd power. So therefore, yung c natin is equal to 3. Diba? So therefore, so yung particular solution natin is y is equal to x to the 4th plus 3 x cubed. So this is our final answer. So we have letter A. Okay? So any questions para dito? So kaya again, simple lang yung sa linear differential equation. Diba? So again, una, diba, kunin nyo yung integrating factor. Once ma-identify nyo yung p of x saka q of x. Pangalawa, diretso na kayo sa general solution. Diba? So pag kailangan nyo ng particular solution, so then gamitin nyo lang yung initial value problem or initial value natin para ma-solve nyo or ma-evaluate nyo yung C. Diba? Yung constant natin. Okay? So are there any questions? Diba? So para sa differential equation. Okay?
Recording stopped.
Okay? So wala kayong questions, diba? So then, okay, so let's have our lunch break. No, so since 12 na. Okay? So again, so let's continue again by 1 p.m. Diba? So again, so I think meron pang ilang problems sa differential equation stuff. Okay? Siguro mga 1 or 1.5 hours yun. Diba? So then after nun, so diretso tayo sa advanced mathematics. Diba? So then sa Probentstat. So again, yung Probentstat naman natin is maikli lang. Diba? Okay? Siguro mga wala pang 30 minutes tapos na natin yung Probentstat. No? So yung pinaka-basic lang kasi yung sinama ko dun sa probability and statistics natin. Okay? Tapos yung sa advanced math naman, it's mostly direct formulas lang. So mabilis lang din yun, mga 1 hour lang siguro yung advanced mathematics natin. No? Okay? So any questions? Okay, so para dito. Okay? So yan. So again, so wala kayong questions, diba? So then, so again, let's continue again by 1 p.m. So again, after lunch. Okay?